Apparently, we've got a bit of a delay because it looks like it went live immediately. Okay.
Oh,
Anyway, hi.
well then.
Hi, listeners or viewers or whatever you are.
We've got a bit of a delay because it looks like it went live immediately.
Okay.
It'll
And
just be
now I
several
have to
minutes
mute
of
my
us
own
still
audio.
waiting.
Make sure to mute your own audio if you haven't already. Hey, listeners. Mark Smith here, N6MTS, and I've got my buddy Vance, N3VEM. I just today realized that those are probably your initials, aren't they?
They are my initials.
Yeah.
Yep.
Yeah, there we go. So I am observant. I've known you for how many years, and I'm only just now figuring this out. Hey, Tom, WHTAM, another person who has their initials as call sign.
Oh,
Um,
well, I know Tom. Boy, it's
yes,
been a while. How's it going, Tom?
yeah, he's in the chat room. Thank you very much for joining us. Um, all right, let's see here. So we've got that. I can still see the chat here. I think we're good to go. Hey, can I make you pin? Nope. Report? Nope. Put you no. Hide. Add as moderator. Managing can manage blocked words and change chat modes in live, and also has the capability standards. It can review, edit. Yeah. You are a moderator now.
Ooh, me?
Snazzy.
Or do you mean I'm a moderator?
Yes, you are.
I don't know if I've ever been granted the privilege of moderator in anything. I don't even know how to do it.
Good evening, Mark VA3HES. Thank you very much for watching us tonight. We are going to be doing a little bit of a code review. Vance has been working on some OHIS devices for his wonderful shack. And he asked me to do a design review of some of the hardware he's working on right now. And then he had the wonderful idea of live streaming it. And of course, I'm going to jump on that opportunity. Good evening, Nerd Garage. He says, good evening, Mark, and say hi to the new kitty for me. Yes, we have just adopted a
Ooh.
new kitty cat yesterday. Her name is Jasmine, and she is beautiful. And if you would like to see what she looks like, go check out my Mastodon at Smitty@halibut.com, where I've been posting videos of her.
Oh, to see that, we actually got well, we got two new small creatures recently. We got a new puppy in December, and we got our fifth child in January.
Oh my
So,
gosh, you're not messing around.
nope.
Great, going great. Currently in Ohio, 20 parks from 1,000 parks. Should have it done soon. Great gravy,
Oh
man.
wow.
Tom is going for the 1,000 unique parks. That is an impressive accomplishment. Okay. Yeah, I don't think we don't have a script or an outline or anything like that. So I think Vance is just going to bring up his screen,
Sure.
and we're set up for a screen share here. So let's do that, and we'll take a look
Do
at it.
you do you want me to kind of explain my use
Yes.
case
Do you
first?
want to do that before you bring up the screen? That works. Okay.
Yeah, why don't I do that?
So what are
And
you trying to accomplish? Let's start there.
yeah, and I can actually, since I know that other camera works, I can actually click here and subject everybody to my bald spot.
Ah, the brightness.
And it's hard to see, but over here to my left, I guess you actually can't see it at all.
Oh,
So maybe
hold
I'll
on,
just
hold on,
switch
hold
back.
on, hold on. Nope, stay there. Okay,
Cool.
now
Yeah,
I've got
it's
your whole
still
screen.
just a little off screen. I'd have to go fiddle with the camera that's up there.
Okay.
Um, but anyway, to my left here at my shack, I have my mixer that all my audio stuff goes through, and then I have six radios at various places around me. There's a couple up to my right, a couple up to my left, my main HF rig in front of me, radio down and to the left, and a radio down and to the right. So like I've got them kind of like around.
Mm-hmm.
So anyway, the audio all goes through the mixer. So my mic that I'm talking into goes into the mixer, a couple computers, other things that I might want to route to the radios. So basically, the mixer has piles of wires running to these six radios. Um, so there's essentially for every radio, I have anywhere from two to four like big fat like audio cables. And when you started talking OHIS stuff, you were talking about the use case for it. But what made my ears perk up was when you said, well, it basically puts all of these signals onto an Ethernet cable. So in my mind, I went, well, while my use case is slightly different, if I can take for every radio, condense 2 to 4 fat audio cables down to a single Ethernet cable, then I can basically empty out the like 3x3 like wiring trough that is
Yeah.
just packed to the brim and like exploding. So essentially, the device that I started laying out for myself is kind of like the station console you've talked about, the idea
Mm-hmm.
being one user and multiple radios, but interfacing it with a mixer where it's probably slightly different is my my user input is stereo line level instead of mic level
Mm-hmm.
that most folks would have. And then the audio coming back from the radios, rather than summing them all into a single headphone, I actually want to keep all of those audios separate. So when I kind of pictured it in my mind, I'm like, okay, so on this device, I have a row of jacks, basically 2/4 inch TRS jacks for balanced stereo in, and then a row of basically mono outs for each radio that I can just jumper right into the various channels on the mixer. So that's essentially what I started laying out. And um,
So the way I'm viewing that is that you're going to have a radio adapter on all of the radios,
yep,
and convert all of the radios to an OHIS interface, and then
yep,
you're going to use shielded Cat5 or Cat6 cables to bring all of those cables back to a single location, and then that single location is not actually doing any mixing; it's just converting from OHIS to line level effectively.
essentially. Yep,
Okay.
yep,
Yeah, so line level stereo output, because that's the receive audio from the radio that's going to go to a stereo input on the mixer, and then a
yeah,
mono
well,
input that'll come from a like a send, or however you get your microphone out of there.
yep.
Okay.
Yeah, the only slight difference being I think I am planning on now it would still come from the radio technically in stereo. My radios are all mono outputs, but I know the
Okay,
OHIS
gotcha.
standard still
Yeah.
has the
Yeah.
left and right. But for my device, I was gonna just sum the left and right
Okay. And
channels
just make
and
a
just do a
mono.
mono out for each radio. Um, because for the audio coming back from the radios, I didn't really need stereo, and
Yeah.
I was like, well, it's probably easier to just
In that
deal with
case,
it in
if all
mono.
of your radios are already mono, then on
You
the
just
radio device you're going to be taking that mono and splitting it into stereo. You don't even need
yep.
to bother summing them again on the other side. You can just take one of the
Okay.
channels and run it in.
Interesting. So that probably does simplify a piece of when I pop the schematic up here, I'll show you
Okay.
kind of what I started working on. So the big caveat with all of this is I have no idea what I'm doing. so
It's all good,
so
man.
this was like like I know a little bit and I know enough that I know like what words to search for,
Yeah.
fire up DuckDuckGo and be like, okay,
Yeah,
so I
yeah.
need something that does this. And then like I steal pieces of schematics out of like, okay, well, I think that's what I need. So if
Yep.
I plug this here and then if I feed that into this other little piece of schematic I found over here. So kind of the
That
question.
that's how I started as well, right? And then when you start doing that enough, you start recognizing some of the
The bits and
repeated
pieces.
functions, and then you spend some time like, all right, so how does this thing actually work? And you start
Yep.
thinking about that, and you just learn it as you go.
Yep.
Like one of the biggest oh, holy crap, that's how that works moments I had was when I was kind of reverse engineering, and by reverse engineering I mean navel gazing at a schematic for a couple of hours of a noise gate, and
Okay.
the I don't remember which noise gate, but it was one from a studio, right? Like a guitar pedal kind of thing, and
Okay.
it used a bunch of op amps, and I could see like this is how the audio through path goes, and then at the end is the switch the MOSFET that turns the audio on and off. And then, but before that, it kind of branches off and it goes through a buffer. Then it goes through a um, one of the pots for that sets a threshold. Then it goes through a not a regulator, rectifier, a perfect or an ideal rectifier, which is something I had to look up at the time about, like, okay, how do I use a diode and an op amp to get rid of that 0.7 volt voltage drop across a diode. So you have an ideal rectifier, and then it goes into like a DC threshold detection thing, and then it controls the MOSFET at the end. And I just went through stage by stage, and I'm like, oh my gosh, that is so simple once you understand it, or at least not necessarily simple, but it makes sense.
Right.
I started to get it, and that was really exciting. Just when you've worked with this stuff enough, you're like, okay, you just kind of take it as a black box. But once you start looking at it from a schematic standpoint and really trying to figure it out, it's kind of magical. So,
Cool.
yeah, you
Yeah.
ready to share your screen? And
Yeah, I'll click to share my screen here,
okay,
and I guess what might be oh, that's the wrong screen.
oh, not that one.
Let's try again. Desktop 2. Boom. There we go.
Okay.
So,
Oh, I'm gonna need you to zoom way in.
oh yeah, I'm gonna need me to zoom way in. And I figure what might be the easiest is if like kind of like walk through like the sections piece by piece. So
Yeah.
maybe I'll just start right here. Whoops, well, that zoom is really touchy. Um, where so this is the input from the mixer. So I'm basically taking a balanced, what is meant to be a balanced left and right, but summing them together. So I threw in just two audio transformers just for isolation of that, all that balanced stuff to this. And then this is a little summing network that I found on Rain's website,
Mm-hmm.
um, to basically do balanced, summing to mono. Um, and I actually built that on a breadboard already, and that seems to work just fine. Um, the one thing I did there in their thing on their website, they showed resistor values that were a lot lower. And then they had a footnote that said, like, but your channel isolation will only be like 27 dB down. If you want your channel isolation
Yeah.
something
The
much lower, it said to like multiply the resistor values times 10. So
well,
so I did that.
there's actually a better way of doing that,
Okay.
but it requires an op amp. Um,
Okay.
yeah, passive mixing like what you're doing here. I don't know. Does my cursor actually show up on the screen? It looks like it
Yep.
does.
Yep. Yeah.
Um, passive mixing like what you're doing is always going to have some crosstalk between the two channels,
Yep.
and coming up into your mixed circuit isn't so bad because that's where you want them to be mixed anyway. Um, how do you mark what is the impedance? 600 ohms, probably.
Yeah,
Um,
those transformers are,
yeah,
yeah.
but the transformers aren't really any given impedance. They're a ratio of impedance.
Oh,
The
right, right.
the actual impedance of the transformer is defined by what load you put on this side. So this is going to be a 4.7 into a 4.7, so about 10K there, a little less than 10K, about 9K, especially when you put it in parallel with a 200,000, 200K. So about 9K there. Scroll up again, or scroll down, I should say. Um, yeah, okay. So yeah, there's nothing down there. Yeah, that'll be good.
Yeah. Yeah, and the thing with the crosstalk on the with passive mixing, with these values they said it should be like 46 dB down, I think is the number that they said. And even if there is a little bit, I don't know that I care,
Yeah.
because for the most part, I'm mostly dealing with mono stuff anyway. And I don't think I'm going to be using those two channels as stereo channels anywhere in my system. I'm
It,
basically just
the big issue is anything else that is using these channels,
Okay.
because it'll backfeed that audio into the source is the
Okay.
problem. Um, so you're getting crosstalk so that anything else that uses this channel will start hearing audio from this channel, and that may not be a big deal. Like you may not actually be doing anything with the audio elsewhere, so it may not be a big deal. But that is the drawback with doing passive mixing like this. But that's
Okay.
okay. Let's move on.
Yep.
We can. I don't
Yep.
want to rat hole on that one thing.
Yeah, no,
So
that's
what is
fine. And then
J4?
yeah, so all this is um I use this symbol because on my actual board I'm gonna put a pin header, and that way I can run wires up to a pot that's on the front. So
Gotcha.
really all this is a for a dual pot that's panel mounted. And this was again another circuit I found basically to make the attenuation adjustable. So in my mind, this is the dual pot that I would turn to basically get this to pad this line level down to mic level, basically.
Um, okay. I assume you have one pot on each side. So like 1, 3, and 5 is one pot, and 2, 4, and 6 is another pot.
Yeah, it's the one that I was looking at. It's like a dual pot. It's one knob, but it's two pots
Um,
because at this point it's technically still a balanced.
yeah. Yeah. Well,
I
hang on.
think I don't know.
Uh, okay. So again, I don't want to rat hole on this. Let's 100. Oh, because it's balanced. Okay, I got you. Um,
Yeah, and from my understanding, this resistor value on like the far side of the pot, if that makes sense, basically just dictates what the lowest, highest. It kind of sets a threshold
yeah.
from what I read, where I found that little kind of pot
You're
based pad
yeah,
thing.
you're the top of the pot is going to be on 5 and 6. 3 and 4 are the wipers, and
Yep.
then 1 and 2 are going to be the ground. So that's going to set your minimum. So with that 100 ohm there, you will never be able to completely silence it. It will always have at least a little bit of audio.
Right.
Okay. Really quickly, Stephen Wilson asks, summing op amp instead. Exactly. That's the way that you prevent crosstalk, is by sticking an op amp
Yeah. Well,
right
and it's
here.
interesting because I waffled back and forth about because I don't know op amps as well, and I
Mm-hmm.
do have a couple in like the audio coming back that we can talk through then.
Yep.
But for the mic stuff going out, does I mean I guess you could do a summing op amp that's unity gain
Yep.
and then pad it down.
Actually, summing op amps are inherently inverting op amps. And inverting op amps, you can actually do a negative gain. So
Okay,
you
so and
could
that's what I
actually,
didn't know
yeah.
because if I know it's based on like the resistor value of the feedback
Yep.
loop,
Yep.
and I looked at the maths, and so when I say I don't know what I'm doing, I don't
Yep.
know what I'm doing, but I read a whole lot of
Yep.
stuff,
Yep. Yep.
and the thing that I couldn't find is if I change the resistance value enough that I like basically flip that ratio, can I
Mm-hmm.
go negative
Yeah,
and
on an
will the
inverting op amp you can. On a
okay
non-inverting op amp you cannot go. You cannot do negative gain.
okay so I may revisit this section at a later date then and do that way because that's what I didn't know is like because technically all I need to do is pad. I'm going from line level to mic level, and because I didn't know exactly if you could go negative gain on those, I was
Mm-hmm.
like, well, I'll just it's passive. All I need to do is pad. I won't get too fancy, but now I'm curious. Okay.
Steven is saying U1A is an example. So U1A is right here.
Yep.
Oh my gosh. Okay, yeah, you put the pot in the gain path. Okay.
Yep. Yeah, and that will get to on that side, because
Okay.
that was a piece where I was like, I don't really know what I'm doing, but here's a circuit and I'll
Yeah.
stick it in here.
Yeah. All right. So where did TSG
So
and TH go?
yeah, so basically that's kind of like that's my mic line then. And
So okay,
because
hold on.
of
Let me make sure I understand this. So no, bring up the whole thing on the screen at once.
oh, there we go.
Okay. So you've got two balanced inputs down here on tip and ring, and
Yep.
then sleeve is grounded. Each of those go through an isolation transformer, and then um, you're passively mixing that. So now we've got a single balanced signal. You run it through a dual pot, um, and so now we have some amount of attenuation on from the sum of those two into coming out here. Okay. Okay. I think I understand all of that. Move on.
Okay. Cool. Yeah, so basically that's the the idea that is that gets me down to mic level then. Um and this is something where I was like I was kind of
Hang
in
on.
the dark. So because I want to
Hold on for one
go
second. Hold on for 1 second. Um that potentiometer is going to be super twitchy.
okay.
Because your impedance ratio is going to want to be about 100 to 1 because you need to drop about 40 dB.
Uh-huh.
And that's dBV, which means it's uh, it's a 20 dB of it's it's weird. It's a 40 dB is a 10,000 to 1 ratio of power, right? But that's only 100 to 1 ratio of voltage because of given voltage into I'm sorry, if you do half the voltage into a given impedance, you'll have 1/4 of the total power because the current also drops by half. Um, or V squared over R. So the power goes down by the square of the voltage. Which means that if you want 40 dB less power, you need 20 dB less voltage. So your voltage actually only needs to be about a 100 to 1 ratio, which means that your pots here are going to be tuned all the way down, but like up just a tiny bit. Actually, that's what the 100 is for. Yeah. What value are these pots?
I forget whatever they said they should be when I looked them up. Uh I'll The one thing I did do is in that data sheet thing, I put the links to the Mauser stuff as I was looking it up so I could find them again.
That's right.
Uh, I want to say a few K at the most. Yeah, these were 10K.
10K.
It's a
All right.
10K pot.
So 10K to 100. Yeah, your pot's going to be basically turned all the way down at that point. You're not gaining anything by having a potentiometer there. You should probably just do a fixed attenuator here.
Just do a fixed
Yeah,
attenuator.
probably.
And what's the um like what's the math on that to know what value of padding I would want?
So if you want to do a 100 to 1 ratio, the resistor on the bottom of the voltage divider is going to be 1, and the resistor on the top of the voltage divider will be 100 times whatever the resistor is on the bottom. So if you use like 100 ohm on the bottom, then the top will be a 10K.
Okay. Yeah.
A technical domain in our chat says, I find it funny that I'm soldering a radio together on the bench here with a professional audio engineer, aka my father, sitting right behind me, and having no clue how any of this works. Well, tell your father to keep me honest if he can hear us, and if I start spouting BS, please correct us, because I'm pretty confident in this stuff, but people who actually have degrees in this sort of thing will probably know way more than I do.
Okay.
Okay.
I just pulled up a sheet so I can make some notes.
Make some
basically,
notes.
if I'm doing, so basically what you're saying is kind of lay out that same thing, but instead of pots, just do a
10K. Yeah.
fixed values. Okay.
Yeah.
Okay.
All right.
So would I lay it out? So basically, just do 10K from here straight.
It would be a
through?
10K from this node to that node, and then 100 from this node to this node, and then 10K from this node to this node.
Okay.
That would actually give you 200 to 1 voltage ratio, actually, because you have to assume this 100 here is split in half for each side. So, actually, you might be able to get away with just, because here's half of 10K. So 4.7K into the 50 ohms on this half, and 4.7K into the 50 ohms on this half. That's about your 100 to 1 ratio. So just these resistors and this resistor here might make a reasonable voltage divider. I'd have to think about that a little bit more. So literally take out this component here and just tie all of these together. Like each side is to a single node.
So you're, well, I can't move that.
No. Well, yeah, you just don't want to drag it. You want to move it.
Yeah. Is that a control click? I don't remember.
I will admit, I had to sound it out. Technical Domain says, I'm just more amazed you pronounce my name right. I'm like, I literally had to sound it out. It's spelled Teknikal. I also spent a long time in the hacker community at DEF CON, and so I got used to figuring out how weird spellings are pronounced.
Nice. So you're basically saying just connect these straight through?
I think so, yeah.
Like that?
Yeah. Stephen Wilson also asked, do you have a virtual ground halfway between the balanced ends? So that's something I was going to bring up. I wanted to see where this ended up. No, we don't. Or at least none of it is defined in this circuit. You would define it right here. You would tie this line of the audio transformer. Stop moving. Pin 5 would get tied to your virtual ground to keep this all balanced on either side. And then scroll back up again. And then the center of this 100 ohm right here would also be tied to ground. So you would split that into 250s. Yeah, at that point, you could probably even do away with this 200K because it's just in parallel with this 100. There's no difference there. So yeah, Stephen, I want to see where this ends up before we make a decision on that, before I make a recommendation on that. But yes, I have been thinking about that. Okay.
Cool. So from here, what I needed to do is get this out to 8 channels. So I basically want to split this 8 ways. And that's where I was like, what gets like, it gets funky. I'm like, do I literally just put in parallel 8 transformers?
So no, because the source impedance of this is going to be much higher than that.
Okay.
So what you actually want to do is you stick an op amp in there as a buffer. So now we're right back at the point of you should just use your mixing amp as your output buffer. So we're going to replace all of this with an op amp in mixing mode and make this a much cleaner solution.
Okay.
So, yeah, let's continue on and we'll take a look.
Then we can circle back.
Yeah.
Okay.
Actually, Stephen, is there any reason not to do a a negative gain mixing buffer amp there, or should we do unity gain and then drop it with resistors? So yeah, Stephen is providing a bunch of feedback in the chat room. Thank you, Stephen. I actually greatly appreciate that. Yeah, and then feed it. Okay, so let's move on. Let's take a look at the rest of it. So
Okay.
actually, hang on. Sorry. So the goal of this here is now you've got a balanced microphone signal that we
Yep.
then want to split out to 8 different loads.
Yep.
So those 8 different loads are going to be, somewhere between 600 and 1,000 ohms load each. And when you put 8 of them in parallel, so 600 divided by 8, your impedance is going to be, around 70 ohms? Basically, your load impedance is going to be something like 70 ohms, or whatever 600 divided by 8 is, because I can't math. Mathing is hard.
No, we have calculators when we
Yeah.
get there.
I guess it would be 7.5 because 8 times 8 would be 64. So yeah, so 750, no, 75 ohms is going to be the combined impedance that is loading this part of your circuit, right? And yeah, and that's going to be more than what can be driven by these 4.7s, or a lower
Okay.
impedance than what can be driven. Although I guess it's actually being driven by that because you got the divide. Yeah. Anyway, the right thing to do here is to stick a buffer amp here, and that buffer amp will be able to drive that low impedance load without too much trouble. All right, so Steven is telling me that we should do a unity gain amp and then drop the gain in resistors afterwards. That seems reasonable. Okie dokie. Let's look at the rest of the circuit.
Okay. Yeah, so basically from there, so I only laid out like 2 of these channels and they're
Okay.
actually the same, but I figured I'm not going to like actually put down all of them because they'll just be
Yep.
repeating.
Yep.
So this is the OHIS connector. I put this pin header in there, which this was notes I was making for myself later, which I may not actually do in the final product. I was just doing this thinking that I want to bring these lines out on pins that I can stick the voltmeter on and stuff like that to kind of test them.
Okay.
So basically, this is just the standard OHIS. So the way I named these, it's just OHIS device one, pin 1, 2, 3, 4,
Yeah.
5, 6, 7, 8. So these are following the pin numbers in the OHIS spec, is what I was working on.
Hi, Kyle. He says he's at dinner, so he can't hear us, but he wanted to say hello, so I'm going to wave at him.
So the push to talk stuff, that's pretty simple because that's basically like a switch. So I have one push to talk jack coming
Okay.
in to put my input device, and then just kind of have it going out to the push to talk for each radio,
Mm-hmm.
and basically a panel mount switch so that I can say let the push to talk engage for this. So basically in
Got
the
it.
line
Okay.
going to each radio, I have a switch so that I can basically push the button if I actually want the push to talk to engage on each radio. So that's
Yeah.
all that this is. Um, so that's pretty easy there. This is the mic input stuff, which I wasn't sure exactly what to do with. So I had those transformers down below, and those transformers were just coming basically back to here for the mic part. So
Okay.
there's not really anything exciting about the mic here once we revisit the other end. But the audio coming out from here, this is like the results of lots of Googling and piecing stuff together. So, and the reason I drew out 2 channels is only because the chips that I was finding that were like a reasonable price and stuff were all dual channel chips. So I thought, well, I can probably use one chip for 2 channels.
Yeah.
So that's why I laid out 2 channels. But essentially, I have the left and right audio coming in. This is an inverting
Mm-hmm. That's a
summing
mixer amp, just
op
like
amp.
that. Yeah.
Yep. And this is something I saw in one of the various places about putting a pot in that loop to basically adjust the ratio to determine how much gain you're getting out of that. Um, and
What's the
then,
value of that pot?
did I write it down or do I have to look it up again real quick? I didn't write it down, but I did save the link. Come on, Mauser, you can do it.
Yeah. Steven and technical, I'll get to that in a bit. I see your comments and I'm thinking the same thing, so I'll get to those in a
This
bit.
was a 2.5K.
2.5K?
Yeah.
Didn't even know those
And
were.
I don't know why I picked that value at the
Okay.
time. I was probably looking at something and that made sense.
Okay. I've never seen a 2.5K pot.
Okay.
So, ones and fives are the common values. So like
Okay.
1K, 5K, 10K, 50K, 100K, that kind of stuff. I guess I've seen 250K, but I don't think I've ever seen a 2.5K.
Interesting. Okay.
So, yeah. Um, okay, so these are the speaker outputs coming from the radio that you are
Yes.
mixing into a single channel. We're going to change how this happens, but and then this is going into a unbalanced line isolation pin 5.
That's
Oh,
just the
yeah,
mic
no,
or
no,
the
no.
audio ground.
We'll be doing
Yeah.
that differently. Okay, got it. Um, and then in your line isolation, and that's going to your balanced. Okay, got it.
Yep.
Tech. Save yourself 2 syllables. Got it. Tech. Uh, I'm probably operating off of too many assumptions. TMA. Look at ULN 2001 relay drivers that can be wire ORed. Multiple radios. Yeah. Okay. Um, yeah, a relay would definitely do it. I was also thinking of a MOSFET, putting a MOSFET on each of the PTT lines. As long as each line gets as long as each PTT line gets its own switching circuit and not just try to put a whole bunch of them in parallel, then I think we'll be okay. A MOSFET is almost certainly going to be a MOSFET to ground will almost certainly be sufficient for this. I'll explain what all of this means to you, Vance, in a bit.
Okay. Yeah, and I mean I know vaguely. I mean, you're using words that I've heard before, and I kind of know what that they
Yep.
make a little bit of sense, but I've not done much with them. So
Yep. Okay. So I understand the receive audio path, and that goes into Darlington pair drivers. Okay. Um, scroll back to the top. I don't know whether you call that scrolling up or scrolling down.
yeah,
Drag the page down so I can see up.
yep, yeah. And this up
Okay.
here is garbage that I may or may not actually use. I was fiddling with stuff. The main meat of it is the audio in and out. Here
Yeah.
was just
Yeah.
me screwing around to say like, hey, I'd like to make those LEDs on those Ethernet jacks flash when things happen. So
Can we make it do things? All right, I'm going to make some notes. PTT switching, don't just put them all in parallel. Mic input, balanced, buffer amp, buffer slash mixer amp. Radio, receive audio. Unity gain pad. Okay. I'm keeping notes of what it is that we are trying to do here. So 4 and 5 are receive audio. What do we have? Oh, so you're using 7 as a ground, PTT ground, power ground. Okay,
yeah,
got it.
7 is the power ground. That's where I was connecting the PTT switch
Unbow
coming in.
1-1. Okay, so you want me to ignore what's up at the top of this?
Yeah, we can. We don't need to worry about this stuff. This was just me
Okay.
kind of screwing around. Well, one of these is literally just like if there's power coming from the radio device, using that power to turn on one of the
Oh,
LEDs
oh, that's a
on
good
the
idea. I like that.
on the
Yeah.
little thing. And then
That
this,
just
I don't know
tells
if
you
this
whether
would,
it's connected or not to a radio.
yeah,
Yeah. No, that's
yep.
good. I like that.
And then this was a circuit that I found somewhere. Somebody was using it to make like a VU meter, but
Oh,
I was just kind of stealing their stuff basically so
all right.
that if there's audio, the one light would like
Yeah.
kind of flicker on and off if there's audio. But that's, I can fiddle with that later. That's not really.
All right. What I want to see is your power supply.
So my power supply right now is just kind of generically undefined as 12 volts.
Okay. All right. But you are, first off, that's wired backwards. What are you, in Japan? Because that's
I
how
don't know.
Japanese barrel
Is it
plugs like to do it.
interesting? Yeah, no, I don't know. This, I just grabbed one of the symbols
Okay.
and it was pre-labeled with V minus and V positive. But
It was?
yeah, which device is that? Or maybe it wasn't.
No,
Maybe I did put those.
connector barrel jack, that's, yeah,
Yeah,
those are
no,
not
that's
labeled in
okay. Yeah,
KiCad unless you've got a different library than I do.
yeah,
In any case,
yeah.
reverse
No,
that, flip that upside down, select it, and just hit Y.
why? Oh, that's a neat trick.
Yep. And X will do the same thing in the other dimension. You'll need to
Okay.
grab your ground and put that back up there again as well.
Oh yeah.
All right. So that, yeah. I
Yeah,
hate
my
that.
yeah, with the power supply, I have 12 volts
Yeah.
everywhere, so I figured it probably needs some kind of like
So
cleaning
yes. So that's going to be
circuit,
the first
but
thing I'm going to mention is that
yeah,
12 volts is not good to run audio circuits on directly. You will want to clean that up, regulate it to a fixed voltage, a good, clean, constant voltage. Um, yeah, the VE on the barrel. Mark notices the polarity on the thing. Yeah, I hate those. Um, sorry. Yeah, let me go back to that. The reason you don't want to put your positive voltage on the outside of your barrel plug is that now it is much easier to
they're
accidentally
short.
short
Yeah,
your positive voltage to a metal chassis.
yeah.
You want to keep the positive voltage on the inside of the barrel plug where it's more protected. Okay, so you want to take that, 13.8 volts plus or minus 15%, and you want to regulate that down to something that's less than 13.8 minus 15%. So a good option is either 5 volts or 9 volts, something along in that range. You will find a lot of stuff that is designed for 5 volts. However, the cheaper audio components want a more voltage than that. So there's a system called, or it's a characteristic of op amps that you want. If you're only going to be running 5 volts, you want to look for an op amp that can work rail to rail, is the term. So normally in the old days, op amps, let's say you had a plus and minus 10 volt rail, right? So that's 20 volts total that you had to work with. But that op amp would not operate correctly 2 volts from the top rail or 2 volts from the bottom rail, right? And so you end up losing some usable voltage on the outer edges of your voltage rails. And when you had plus or minus 10 volts, that wasn't a problem because, that leaves you with 6 volts in the middle. And when you're doing line level, you really only need 1 or 2, maybe 3 usable volts on the inside. But if you've got a 5 volt supply, you still lose 2 volts from the top and 2 volts from the bottom. And so that leaves you with 1 volt in the middle.
Right.
And you're going to start distorting and doing all kinds of bad things. So if you want to use a 5 volt supply, you need to be careful on which op amps you're selecting and make sure that they are designed for operating on a 5 volt supply. Going with a 9 volt supply Most op amps will still work on 9 volts, although double check that because things that are specifically designed to work for 5 volts may have an upper limit of 5.5 volts.
Okay.
But yeah, so like 8 or 9 volts is a good, give me some more headroom.
Okay.
Steven is asking why not work on 12 volts. I don't want to use the 13.8 volts plus or minus 15% directly because I want to have something regulated and filtered and cleaned up. And 12 volts, literally 12 volts, is I think 13.8 minus 15% is like 11.9 or something like that. It's
Yeah.
within the spec, whatever the numbers are. Within the spec, you don't have enough dropout of your LDO of the voltage regulator.
So to take the 12 volts to 9 volts, it is like this specific circuit to do that picky, or like, because I literally have several like 12 volt to 9 volt little sealed box buck converter units laying around here. Could I
Oh,
just slap one of those in and call it good enough?
so yes, but that won't answer the next problem, which is that you also need a half of whatever you choose power supply.
Okay.
Right? So let's say you're going with 9 volts. That means you also need a 4.5 volt power supply. And if you've got a one of those little buck converters that will go down to 4.5, then maybe you can get away with that. Although the cheap ones are likely to be noisy.
Right.
um, yeah, I'm sorry. I'm reading the chat room trying to figure out what they're mentioning. 12 volt instead. I'm thinking 12 volts dividers to get. Yeah, I'm also trying to keep the power supply on this simple. Yeah, Stephen Wilson, voltage divider, and that becomes your virtual ground. So I've been bit on this recently. When you have a lot of circuits that are loading your virtual ground, the source impedance of an op amp that you're using to buffer your voltage divider starts becoming significant. And when your virtual ground has has ripple on it, or more importantly, has your audio superimposed on it, i.e., the source impedance in your op amp becomes a significant fraction of the total impedance. Now you're starting to put audio in places that it shouldn't be, that should be a fixed voltage, and you end up getting oscillations. And you get a lot of crosstalk and noise and various other things. I just got bit on this with my contesting console, and I ended up having to design the cutest little circuit board in the world. I don't have any within easy reach. I'll go get one from the workbench. It is 5 millimeters by 6 millimeters. It is meant to replace an SOIC 8 on a circuit board. So it's got 4 little castellated edges on either side, and it's just this tiny little circuit board that you remove an SOIC 8, the op amp, and put this in its place, and it's got a 2.5 volt voltage regulator on it. So I have gotten to the point where if I don't have plus and minus supplies where I've got a literal ground, then I will use a positive supply and a half supply, but I will still use a voltage regulator for that half, not a voltage divider. And since he's going to be having a whole lot of different loads on that virtual ground, if you bypass the crap out of your virtual ground, now you have a capacitive load on your op amp, and that causes the op amps to oscillate. I've also learned that one the hard way as well. So you can't just throw 100 microfarads on the output of your op amp. Bad things will happen. The op amp will start oscillating. Anyway, so what I'm going to recommend is that you put 2 voltage regulators. We're just going to go with linear voltage regulators. None of this is going to draw so much power that you need to worry about switching. I would just put like a 7808 or a 7809, or even better, just do some some adjustable regulators, like a 317, and there are better options than that for audio, but something like a something like a 317, which is an adjustable voltage regulator. So you can, it's looking for 1.25 volts between ground and the adjust pin, and between the adjust pin and the output. And so you put a voltage divider between the output, the adjust pin, and ground, so that 1.25 volts appears between the output and the adjust pin, and then whatever voltage, with the same amount of current flowing through it from the adjust pin to ground, so that the top is what you want it to be. There are calculators you can use to figure this out. So let me show you what this looks like. Go to your component picker, and there are better components to use for this, but we'll just start with the easy one. Type an LM317. Do the SOT 89. Yeah. Drop that down. Okay. And then drop two resistors, R_small.
Do you like the small or the small US?
I just go with European. So
two of them, you said?
What's that?
You said two of them?
Yeah. One there, and then one between the output and the adjust.
Whoops. I forgot to change back my select. So one of them goes here and one between the output.
From VO and adjust, yeah.
VO.
Okay, first off, your R15 is not touching the pads aren't lined up.
There we go.
And then draw a line between pin 1 and the bottom of the resistor. The bottom of the R16.
So from there to there?
Yeah. Yeah, it was right there. The bottom one. Yeah, right there. Oh, you've got a little whisker hanging off of that.
Oh, okay.
Thank you, Nerd Garage. He says, my favorite part of these videos is my way of explaining things. I get rather animated. Okay. And we will want to throw some heavy capacitance out here. So add another C_polarized_small. Yep. From 2 to ground, pin 2 to ground. Oh, nope. Just drag it out next to R16. You want the positive side on V out, not the negative side. Yeah. And then connect those.
Oh. It's always fun, like, doing this stuff then when you have people watching you.
Oh, yeah. Throw a couple grounds down at the bottom of R15 and the bottom of C9.
The bottom of R15 and the bottom of C9.
Nope. Try that again.
Oh, whoops. R15 and... I gotta move these words out of my way. Hold on. And the bottom of C9.
Yeah.
Meaning here?
Yep.
Okay.
All right. And then copy that ground and C9, copy them over and put them on the input as well. No. Don't put a capacitor between pin 3 and ground.
Oh, the both of them. I got you.
Yeah. Okay. Man, clean up those words. That's making that hard to read. Oh, that's one way to do it.
Just make them go away.
Who needs values anyway?
I can always put them back in once
Yeah,
I add them.
C9 and C10. You probably want those to be at least 10 microfarads. Larger is always better. Well,
micro is the U, right?
Yeah, UF, correct. Of course, you're setting a value that you can't see.
I can re-show it then.
Yeah, just check the show box right there. Yeah, there you go. Yeah, do the same thing there. Oh, you did. Yeah. Selection is hard.
Oh, jeez.
Oh, yeah, you're right. It is already there.
It just went way over there.
Yep. And then yeah. Oh, wow, it actually grabbed the right thing. I'm impressed. Okay, so the values for R16 and R15 are going to be dependent on what output voltage you want. Okay. So you're going to make a voltage divider using R16 and R15 such that the voltage across R16 is whatever the threshold voltage is for that 317. On a normal 317, I think it's 1.25 volts, but you look at the data sheet to figure out what it is, because different voltage regulators have a different threshold voltage for their adjust pins. And then the value of R15 is whatever value you want to put there to make the voltage divider between these two, make it such that this is your desired output voltage, this is your desired output voltage minus the threshold voltage, and this is ground.
Okay.
Right? So really, you plug that into a calculator on the data sheet of the adjustable regulator.
Okay.
So if we're going to do a literal 3M or LM317, then we can go look up that data sheet. But right now, let's just wave our hands at it and say we've got the appropriate values there. Okay. And then we're going to do the same thing, make another one of those, copy all of that, and put different values in for R16 and R15 so that the output voltage is, instead of being 9 volts, make it 4.5 volts.
Okay.
Right?
Yep.
And then you're going to take the V plus from your input pin and put that onto pin 3 of both of these regulators. Right? So your 13.8 volts plus or minus 15% is coming into the input of both of these voltage regulators. Oh, yeah, that works. And then on the output over here, you'll make that, plus 9 volts. There is a power flag for plus 9. Plus 9V.
So that's just on the output there, you said?
Yep, just like that.
Okay.
Actually, so Steven and Tech both asked the question, is there any reason that we don't have you don't want a 9 volt on that one, you want a 4.5 volt?
Oh yeah. Sorry.
So Tech, no, it would not. So Tech asked the question, would it be any better heat-wise to take the 4.5 volt supply off of the 9 volt rail? No, because whatever current the 4.5 volt supply is drawing will have to be dropped from the input voltage. Whether that drop happens in this regulator or in this regulator doesn't matter. Let me rephrase. It's not going to be any better from a total heat dissipation standpoint. You're going to be dissipating the same amount of heat total between both of these devices. Now, I'd have to run the math to figure out whether drawing this from this one's output would make the heat dissipation more balanced or not. That's a good question. I don't know, but it's not likely. But it's not going to change the total heat dissipation. If you need so many milliamps at 4.5 volts and so many milliamps at 9 volts, it doesn't matter where it comes from. They both need to be dropped from the 13.8 volt input. So volts times amps equals power. Yeah. Steven says, if you series it, you're right. The second regulator will be a lot cooler, but the first regulator will get hotter by the same amount because conservation of energy. Okay, so now we've got two supplies, a 9 volt and a 4.5 volt. Your 4.5 volt, actually, I wouldn't bother tagging it 4.5. Go back up to your power flags right below the component picker. Yeah. Type in GND, and there are a whole lot of grounds here. I like GND-A because that is an analog ground.
Okay.
All right. So we are going to use ground A as our virtual ground. All right. Real ground is going to be our minus supply. And 9 volts will be our plus supply.
Okay, say that again.
So we've got 3 voltage sources. We got real ground coming from our power supply.
Okay.
Then we've got a 9 volts that's being regulated from the 13.8. And we have a 4.5 that's also being regulated from the 13.8. So I've got 3 points of power.
Okay.
Choose the middle one as our analog ground.
Okay.
Any analog circuit, we will use that middle power supply as the analog ground. And then whenever we power a chip, we're going to give it our positive and negative supplies, which are plus 9 volts and ground. Okay?
Okay.
Now, the only problem with this is that we have our ground up, our analog ground up at 4.5 volts relative to real ground. And all of the audio coming in and out is going to be around real ground. So we need to do something to take audio plus and minus real ground and bring it up to plus and minus 4.5 volts. So we're going to do that in places like our audio isolation transformers, because that is a great use of an audio isolation transformer. So let's go back down to the first audio isolation transformers that we were looking at. Those right there. So you've got a balanced signal coming in here, and that's going to be moving up and down around some point. We don't actually want to force it to any point here. We're just going to let it go plus and minus whatever the driver of this signal is putting out. So whatever your mixing board is putting out. Spoiler, there's a very good chance that it's this ground right here. So in theory, we could tie this to that. We don't need to. We don't need to. So we're going to take that balanced signal, and then it's going to get coupled and create a positive and minus voltage around this pin right here. Right? Because we have that center tap. Yep. And if that center tap is going to be assuming all of this is properly balanced, that center tap will be a fixed voltage. It won't move, right? It'll be a node because you got each side going up and down around that center tap. So what we're going to do is we're going to put our ground A on these center taps. And we're going to say, all right, signal, you are going to be plus and minus 4.5 volts. Or audio superimposed over a 4.9 volt DC voltage. Yeah, rotate it. Yep, there you go.
Can you rotate it before you place it with a keyboard shortcut?
Yes, you can. R.
R, okay.
All right. So now, this entire system here is, by definition, going to be putting our audio signal balanced around our analog ground. Okay? So now everything upstream from here, or downstream here from here, I guess, is going to be ground A referenced. So let's go up in the schematic. Once you clean those up, that's fine. Okay.
Yeah, and I can go back and move that stuff around later.
Okay, so let's go ahead and put our buffer amp here now.
Okay.
Remove the 200K. Remove the 100K, or the 100, excuse me, and all of the bits in the middle here. I mean, you probably want to save your okay. You probably wanted to save your test points and your output labels, since that's what's going to be used elsewhere in the schematic. But yeah, get rid of all of that. Do you know about dragging from the left versus dragging from the right?
No.
All right. When you drag from the right, it will only select everything that is completely enclosed in your drag box. That's if you drag it from the left. If you drag from the right, it will select anything
it touches
that is at least somewhere in the select box.
Okay, interesting. I did not know that.
Yeah.
Okay.
Okay. So let's grab an op amp. Go create another op amp. So 4562, those are good op amps. That's a fine op amp. At least for our use case. All right, rotate that so pin 1 is up. Tech is confused. Wait, what? He says. Okay, so now we're going to be building ourselves an inverting op amp, right? So you've got a resistor from your source into the negative pin, and then a resistor from the negative pin to the output. That's what makes an inverting op amp. And then your positive pin is tied to ground. So in our case, okay, sorry. I was just describing to you how you do it with a single-ended signal, not with a balanced signal. Oh, did that with selections. Oh, he's talking about the selecting from the left and selecting from the right. Oh, yeah. Yeah, it's really handy.
So, is there the only reason... So the mixer is balanced.
Yeah.
But we can, after the transformers, we can just unbalance it, right?
If you want to make this, if you want to process it internally as unbalanced, yes, that we can do that.
Yeah, and I don't know what makes more sense.
So actually with OHIS, we do want it to be unbalanced because the negative side of it has to be a real ground. It cannot be a push-pull, unfortunately. Now, it is its own separate dedicated ground so that it has its own return current path, which allows the consumer of it to still treat it like a balanced signal and eliminate some common mode noise. But this op amp is going to inherently output an unbalanced signal. But we are going to treat it balanced coming in because that will remove any common mode noise that may have been picked up on the cable. Okay, so we've got a 4.7K coming in, and go ahead and tie that to the positive pin.
The 4.7K?
Yep, right, yeah, so that one right there to pin 3. Okay. And then grab another 4.7K, like just copy R1. Or there is fine, whichever, copy whichever. And then put it between 3K and ground A. I would have it going left out to the side, out to the left side.
So you said between 3 and ground A?
Rotate it. And then, down from there, I would put it like, I don't know if you can see my cursor right now, but just keep it out of the way, right? Yeah, like right there. And then copy your ground A and put it on the other side. Okay. Then we're also going to take the other lead here coming from our mixer bus, the balance mixer, that one there, and put it up to pin 2. And then we're going to copy another 4.7K and put it kind of right where the U4A is. This is going to be our feedback resistor. So
Okay, so just like drop it right in here.
Yeah. And then tie the bottom edge of that to pin 2. Okay. What is TSG and TH? What do those mean?
That was, I forget. They were abbreviations that meant something to me, and it was just going to the input of these transformers before going to the mic.
Oh.
I think it was I don't remember, something signal ground and something hot. I don't remember.
Okay.
It meant something to me at the time.
Okay. So if TH is hot, then we'll do that. Okay. Then create pin 1 or connect pin 1 to the TH line. So go to the right. Bloop, right there. Just get rid of TSG at all entirely. We're going to use ground A as that. And get rid of the test point and the traces and everything. Okay. Go ahead and get rid of the pot as well. So now we have a unity gain. So the output, what's on TH right there, is going to be the unbalanced sum of all of the inputs. Okay? So the inputs are balanced. Go ahead.
So 4.7K going in there, 4.7K going in there. That's good. Okay, I'm up to speed. I just want all my crisscrossing lines here.
Yeah. So what you've built is a mixing bus, and it's a balanced mixing bus, which is neat. So we've got the positive sides coming over here, and this is how a non-inverting op amp works, right? You have a voltage divider. Actually, that voltage divider usually comes from the output, so never mind. I take that back. But we've got, some amount of current coming into this one. Your positive and minus on these are virtual grounds, but that's not true when you're doing it this way. Never mind. Anyway, this is how you consume a balanced signal into an op amp. Okay. The op amp will now take the difference between these two voltages, and the output will be that difference plus ground A.
Okay.
Will be ground A plus the difference between these two voltages, right? So ground A is our 4.5, and then the op amp is inverting one of these and summing it, so subtracting them basically, and that subtraction is what gets rid of all of the common mode noise. Anything that is common, any noise blip that causes both of them to go up and down at the same time, when the subtraction happens in this op amp, that noise goes away. That's why you do balanced signals. That's the big advantage to a balanced signal. And now we have the difference of that coming out here. Okay, Stephen.
So in theory, we've got it through the op amp. It's unity gain. It's now unbalanced, and at this point, it's still line level, right?
It is still line level here because we haven't attenuated it. So that's exactly what I was going to ask Stephen about. So he recommended that we keep the op amp at unity gain, which was what we've done. And then if we pad it after this, that's going to increase the source impedance. And I'm hesitant to do that if we're trying to drive a 75 ohm load. do we really want to do that? Or are we stuck putting another buffer amp after this? So we've done our mixing and getting rid of common mode. Then we voltage divide to get down to the level that we actually want, and then put the other half of this and put another buffer at the output. Is that what we should be doing? That would work, but it seems a little overly complex. I guess I don't know what the impact is of putting a negative gain on this op amp there. I know it can be done, but I also know that some op amps don't even like doing unity gain. Some op amps don't operate well unless they have some gain in them. A voltage follower configuration. Okay. So just do a pad out from here and then a voltage follower after that. Yeah, I guess that would work. Okay. So let's do 4.7K. So go ahead and, since you're doing a bunch of 4.7s, throw a... We want a 100-to-1 ratio. So if we did a 4.7, it would be 470K. So put down a 470K from TH. Well, okay, no. We're going to take TH off of this line. 470K from pin 1, from that output node there. Not literally pin 1, but just this output node. Yeah, right there is good. And then make that one 470K. Okay. And then now copy another 4.7K and connect it to the right of that 470.
To the right, my right.
Yeah, right there.
Here.
And then stick analog ground sticking out of the right of that one. Okay. Get rid of this green node sticking up from there. Yep, get rid of that. And then create a green node. No, don't get rid of that one yet.
Oop.
Control Z. You got it. Okay. Create a node, a green wire going up from between these two resistors, R19 and R20. And then label that TH. To ground A following it. 4.7K to ground A following it. Yeah, isn't that what I just did? Or are you, yeah. Okay, got it. The stream is behind me. Oh, curses. I lied. Take TH off of that. And get rid of that. Well, no, don't get rid of that line. Copy your op amp. Do U4B. Yeah, it's going to do that. Okay. Edit. Hit E. Change it to U4, and then down below, change the unit to B in the general section. Yeah, right there.
Okay. Is this we're going to do with one of those dual chips? Is that what you're getting at?
Yeah.
Okay.
Now drag this such that pin 5 is connected to that green wire sticking out of it. Okay. And then, drag it down. You got it. Connect pin 6 to pin 7, so the negative input directly to the output. Okay. Now, TH is on that node that you just created. The pin 7 output node. Yep. Okay, so let me explain what we just did. So down on the bottom with unit A, that's our balanced input summing amplifier, what we described before, right? And then we take the output of that on pin 1, and we go through a 100-to-1 voltage divider. Technically, it's 101-to-1. Who cares? It's a 100-to-1 voltage divider. And that's going to take your roughly 0 dBV line level signal and bring it down to minus 40 dBV microphone signal. So electret microphones are typically somewhere around minus 45 dBV. I'm assuming that your output on these is not going to be full voltage the entire time. Like the output, the line level output from that is not going to be plus or minus, the 4 dBV or whatever it is. Like you're going to have the volume cranked down at least a little bit. So
yeah,
you can adjust it at the very least.
Yeah.
So you'll go ahead.
Now, so I think I've understand the differences between these. So like dBV, I know is in reference to volts. A lot of the stuff on the mixer is dBu, which I understand is a reference to something that's not actually quite a volt.
Yeah.
And then because a lot of when I was looking in the back of the mixer, like, I don't know, what numbers do I need to know? A lot of it was dBu, so I figured that out. And then my mixer, but not all mixers, on all of the input channels, I can pick between what they consider for commercial gear or like consumer gear. So I can select whether stuff is incoming at, it's labeled as 4 dB and negative 10 dB. The 4 dB I assume is dBu. The negative 10 dB is what?
Is dBV.
Okay.
That's the annoying part. Yeah, the definition of line level, it's a disaster.
Okay. But now that I know it's dBV, that's what I couldn't figure out. I'm like, it's negative 10 dB, but dB what?
Yeah, and actually, I can't remember which one is dBV and which one's dBu. But
I know the 4 is definitely dBu because that I saw in the manual. So
so I cannot explain what dBu is. I read it once. It seemed stupid, but at least I understood it. And then
I read it very recently, and it basically starts at, instead of 1 volt, it uses a base unit of, it was either just a little less or a little more than 1 volt, and it had something to do with telephone systems and Art Bell.
The important part is that the difference between the two is a constant. It is a constant multiplier. It's like 1.4 something. I don't remember what it is.
Okay.
So you can easily convert between them by adding a constant to your dB number or multiplying a constant by your times number, right? Because that's how logarithms work. And furthermore, if you are working exclusively in one unit or the other, it doesn't matter because everything is just relative to everything else.
Right. Yeah.
Right. As long as you're operating exclusively in one unit or the other. Now, do you understand the difference between 10 log the multiplier versus 20 log the multiplier?
It's been a long time since I did logarithmic math, so no.
Well, it's not so much the logarithmic part of it as it is the why is there this random times 2 that applies sometimes but not other times. So the way I learned this, and I finally figured this out just like a couple of years ago. I'm 49 years old. I've gone through most of my career doing electronic stuff, never understanding this, even after attending electrical engineering courses at university. And I never fully understood this until just about a year ago. Back up. Bells is a unit of power. Okay? A bell is always power. Okay? So a decibel is 1/10 of a bell.
A bell. Okay.
Okay? So a bell is 10 times the power. It is a relative measurement, right? So it's a multiplier. So 1 bell above 1 watt is 10 watts, right? And that is 10 decibels, right? So 10 decibels above 1 watt is 10 watts. Another 10 decibels from 10 watts is 100 watts, right? Because this is how we always think of decibels when we're talking about like antenna gains and whatnot. Now, when things get weird is when you start using decibels to measure or to reference something other than a power unit. Okay? So if we're going to use decibels to refer to a voltage unit, to a unit of volts, okay, the bell is still referencing the power.
Okay.
Okay? So if I want to take from, I'm going to use crazy numbers. We got 1 volt at 1 amp into 1 ohm. Yeah. And that produces 1 watt. Right? So we got unity values all over the place. If I want to increase my voltage by 10 decibels, what I'm actually doing is increasing the voltage so that the power is up by 10 decibels. Let me change that. If I want to increase this by 20 decibels, right? So I want my voltage that's normally 1 volt, and I want to increase it by 20 decibels. That does not mean increase the voltage by 100 times. That means increase the voltage by 10 times, because that will also increase the current by 10 times because of Ohm's law, right? If V goes up, so does the current. So they both go up in the same ratio. So the 10 times voltage and the 10 times current equals 100 times power.
100 times power. Okay.
All right. The other way to look at that is power equals V squared over R. It's that squared there, right? That squared in that power equation is why 20 decibel volts is only a 10 times increase in voltage, not a 100 times increase in voltage. So if you were trying to do a 10 decibel, then it would like be a 3.3 volt or 3.3 times, root 10, whatever root 10 is. It's pretty close to 3.3 times voltage increase. So anyway, the point being that the when you're talking about voltages, it's actually 20 log the multiplier, not 10 log the multiplier. But when you're doing power, it is 10 log the multiplier.
Okay.
So yeah, I made it into my late 40s before I understood all of that shit.
I'm only in my early 40s, so I've got a few years to figure it out.
You're ahead of the game. All right. So when we're talking about microphone signal levels, an electret microphone is hand wavy, minus 45 dBV. So let's call it minus 40 dBV to keep the math easy. That would be a 1/100th of a volt, 10 millivolts. Right? Because it's only 1/100, not 1/10,000th, even though it's 40 dB. Okay. So that's why we wanted to do a 100-to-1 ratio here. So we want to take this signal and make it 1/100th of what it was coming in, because these are line level and this needs to be microphone level. And so we need to drop it by about 40 dB.
Huh.
And so we do a 20-to-1 or 100-to-1 ratio here. Okay, so now this pin here, pin 5 on the top op amp, is seeing a signal that is 1/100th as strong as pin 1 on the bottom op amp. We feed that into the positive input, and then the negative input just gets tied directly to the output. That is what's called a voltage follower. Okay. That op amp provides no gain, it does no attenuation, it has no impact on the signal. Whatever the input is on the positive input is what will come out the output of that op amp. So there is no impact. That is called a voltage follower. So it's not amplifying the signal, it's not attenuating the signal, it's not filtering the signal, it's not doing anything to the signal. But what it is doing is providing a very low impedance output.
Okay. And
Okay?
that's because we need to worry about the 75 ohms.
Correct.
Which
It should be able to drive a 75 ohm load, no problem. Whereas this 4.7K is what would be the load otherwise, right? So the source impedance at pin 5 on that op amp is 4.7K. And if you try to drive a 75 ohm load with a 4.7K, that you build a voltage divider. You got your load at the bottom and your 4.7K at the top, and that's going to, drop that voltage by another 100 to 1.
Okay.
But we don't want to do that. So we need a very low source impedance, and that's why the voltage follower is there.
Okay.
Okay. So
well, continue.
Okay.
You're the guy who knows what he's doing. I was going to ask a question, but you're probably going to answer it.
Well, no, go ahead and ask your question.
Well, so by doing this through the op amps and having the virtual ground in here, because we have that virtual ground point.
Yep.
Does that eliminate the need for transformer isolation?
Oh, no.
No?
No.
Okay.
In fact, we need the transformer. Well, there are a couple of different ways to do it. We can use the transformers to get rid of that bias voltage, because now all of our audio is 4.5 volts above the real ground, and we need it we need it around real ground on the output.
Okay.
Right? So we need to get rid of it now, because we're going to send it out a signal that is expecting that we're going to send it out a port that is expecting that signal to be above and below ground.
Okay.
So let's go back to where TH is consumed. I saw a bunch of transformers going into connectors.
Yeah, and we'll go just on one of the channels that I didn't draw anything on yet.
Okay.
And I can refer back to my old one when I look at my notes. So let's go over to this fourth one. So here's where TH comes in, and we don't need this TSG.
So what we're going to apply to that instead is ground A.
Ground A.
So now TH, I don't know what T stands for, but our hot signal is going up.
I don't remember what the T stood for either. I swear it meant something to me when I made it.
It's T for microphone. So now we are creating a fluctuating voltage in that coil, and then it's going to induce a voltage on the other side. So let's go take a look at what those other ones are. So mic 4 and 043.
043, I think, was the mic ground, and mic 4 is going into a capacitor before going into the mic signal.
You can remove that capacitor now, because that capacitor is needed to block DC voltage, but that transformer is doing it for us.
Right. Because, whoops.
Steven asks, shouldn't pin 3 be ground or ground A to CT? No, because on the primary side of the transformer, we have unbalanced audio. So we want that unbalanced audio to be across the whole coil. And since the audio is already going up and down above and below ground A, we want the other side of that coil to be tied to ground, which is ground A. It's on the output side that we want everything to be ground referenced. And so, whoopsie-doo.
No, this is the dragging left and dragging right stuff. There we go. And I'm just going to change these numbers to 04.
Go for it. I'm trying to figure out whether we need to tie pin 3 to ground or whether we could just leave it float.
I'm off by 1.
I think we can just leave it floating. think so.
One of these things, it feels like there's probably a shortcut for edit.
E.
E.
Voltage going negative to
And
ground
as
A
I
on the
do
transformer.
this, so the mic pin on OHIS is
3 and 6. I can't remember which one's
okay.
ground.
Yes, 3 must be the ground.
Okay. You're going to have, Steven is saying, really? You're going to have voltage going negative to ground A on the transformer? Yeah. I mean, I don't want any DC through the transformer, right? So since the analog signal is biased to ground A, I want the other side of the transformer. I'm going to put the analog signal biased to ground A on one side of the primary and then ground A on the other side of the primary. So it'll go up and below. It'll, have zero net DC current is what I'm looking for.
So, pin 6.
The full signal positive to one terminal on the other side of the transformer does your isolation. If you use the center tap, then you have the full signal positive to one terminal and the other side of the transformer does your isolation. Well, I mean, I know that the transformer is doing the isolation. I could see an argument for putting ground A on the center tap, but I would want to leave the other side of that coil undriven. Definitely not to ground, because then I would have, ground A to ground going DC through the second half of that coil, which I definitely don't want. I guess I see your point that putting TH across the entire coil, we might be losing half of our voltage here somewhere, so we might be losing 3 dB. It depends on how these signals are interpreted on the other side. There's a good chance that the other side is going to be treating these as a unbalanced signal anyway, tying one of these to ground. We have a D-pass, DC
I would
path
assume
there's a heart in the way. I'm assuming that's don't want. Sorry, it's you don't want. Correct. I mean, I definitely don't want a DC path through that transformer. I don't want to saturate it any more than we have to. Okay, so with your hot signal here and ground A here, that'll put the entire voltage across. Correct. I do not want to short 4.5 volts to ground through the transformer. So I definitely don't want to use ground and ground A on any of these pins. I'm only going to ever use one or the other. Yeah, okay, cool. All right, so TH to ground. And so your audio is going to be induced over here, and on the other side, you're going to have that audio going. So pins 3 and 6 are the microphone line. The only question that I have is whether we need to tie one of those to ground, and I don't think we do. Because the other side will do the ground referencing on its ground. And the worst case is that we might have some DC voltage across this gap. But if we consider this coil to be entirely in the ground domain of the other side of this cable.
The radio end.
Yeah, the radio end. I think we can do that. So I don't think we actually need to tie either of these to ground.
Okay.
So just leave it like that. Connect this one to pin 3 and that one to pin 6, and make sure that pin 3 and 6 are not connected to ground in any other way.
Anything else?
Yeah.
Okay. Cool.
Yeah.
Okay. So then let's see, 1, 2, 3, 4. I'm just gonna move.
So that's the microphone side of this.
Yeah.
Kind of wrangled.
3, 4. I'm gonna just move some of this crap out of the way, and then I'll make it all pretty later. When I'm on a work meeting that's incredibly boring, I'll sit here and kind of tidy up stuff.
I do the same
I pay
thing.
100% attention at work all the time.
I do the same thing while we're recording Workbench. If I'm being honest.
Okay. So that gets the. Okay, so that adds a couple of like op amps to right at my input.
Yep.
But it does not feel complicated and scary, so that's good.
Yeah, and it's only one because you've only got one mic coming in, and then it's being split out to a whole bunch of outputs.
Yep.
You may want to put a partial load on the other side of that transformer. Go back to that transformer. I would stick a 10K across that output from 043 to 046.
Okay.
Just so that the transformer doesn't have no load. That 10K in parallel with whatever the load is on the other side is not going to be a problem. But if the other side is infinite, no load at all, you don't want that. I think it'd be better to put a lower limit on the load of this, or upper limit on the impedance.
Okay.
Okay, cool.
So now, what makes sense to do we want to look at the audio coming in? Because in theory, it's basically all we need to do is take. So
yeah, I think you've actually got it pretty much. Yeah, so you're not doing any transformer isolation on the headphone inputs. Which feels a little bit weird because you are transformer isolating the microphone outputs. So if you really want
my thought there, again, this is the
Yep.
guy who doesn't
Yeah,
actually
yeah.
know what he's doing, is I was putting all of the transformers on like the balanced side, and then assuming everything on the other side was going to do whatever it's going to do in its unbalanced state, because I think pretty much all ham radio gear operates in the unbalanced space.
Yeah, it definitely does.
Now, if it makes sense to put a transformer in for other benefits,
ground isolations, I mean, like it's just to prevent ground loops, right?
If we don't connect, if each channel grounds are treated separately.
But we're only doing that on the mic right now.
Okay. Yeah.
Right, like the way you're doing it right now is that all the headphone grounds are going to get tied together.
Are they? I don't think they are right now the way I have it drawn.
Pins 4 and 5 on the OHIS, which are 7 and 9 on that jumper. One of those is audio, the other one has to be ground. You need to ground pin 9 on that jumper. Because that's the ground that the headphone is referenced to.
Oh, okay. 025, yeah.
So you would have to ground that to provide the headphones a return path.
Oh, yeah. See, I didn't actually ground it. Like, I kept it separate everywhere. So, like, 025, 025. And then on this side, I went 02,
okay.
015, 015. Like, so I kept them
Yeah.
separate because grounds, I'm always like,
so that,
I hear the term ground loop and I go, I don't know. I don't want to connect anything.
Yep. That is almost the right way to do this.
Okay.
So that would be the right way to do this if you had a positive and negative power supply.
Okay.
right? Because 025 is a real ground.
Okay.
But the op amp U1B does not have a negative power supply below real ground. So anytime 024, the signal, went negative from 025, the op amp would not have any power to actually do anything with that, and it would distort. You'd lose the bottom half of your audio.
Okay.
Right?
So I need to put in the...
So one way to do this would be to put that, those 10 microfarad capacitors you're using to isolate the signal.
Yep.
You could put another 10 microfarad between 025 and then another 1K and put that into the positive side. You're basically treating the headphones as balanced audio.
So basically from 025 through a capacitor and a resistor
to pin
right
5 on the op amp.
024. Okay.
Right?
Oops.
Yep. And then remove that label because that node is no longer 025. 025 is now going to be on the input of that capacitor. And then put another 1K from pin 5 to ground A.
From pin 5 here?
Yeah, we just connect it to the bottom of the other resistor, bottom of R22.
Whoops. No, that didn't go quite where I wanted it to.
Nope, it did not. There you go. And then put ground A on the bottom of that. Okay. So, what you have done is you have created another balanced input op amp. Except that since both... Oh, shoot. No, because the return current is... Oh... Hold on. I think R22 and R23 need to be 500 ohms. They need to be half the value of R9 and 10. Now, 500 ohm resistors are going to be hard to find. So you may want to do something else that you can do a 2-to-1 ratio on. So let me explain why. If you ignore 028 and C6 and R10, so ignore the right half of that mixer, right? So we're just looking at 024 and 025.
Okay.
Right? So 024 comes through the 10 microfarad, which is blocking DC. So the upper half of this, Stephen, where do you hook up power and ground on the op amps? It's part C of the two, right there. So it's another unit on the page. It's just not near the actual op amp itself. Keeps it cleaner. But anyway, so 024 and 025, you're treating it as a balanced input, right? So the 10 microfarad caps are just blocking DC. So it allows one side to be ground referenced and the other side to be referenced to ground A. Okay?
Yeah.
And then we have balanced, matched amounts of impedance. So R9, which is a 1K, and before you changed R22, it was also a 1K, and I'll explain why it's 500 now in a bit. But pretend that those were still 1K, okay? So you've got the balanced amounts of impedance coming in from 024 coming into pin 6, and then from 025 coming into pin 5. And then on the negative input, we have a feedback resistor to the output. And on the positive input, we have that resistor going to ground. Okay? That should look exactly like the other one that we had, the other mixer that we had for the microphone signals. Okay?
Right.
Except for that the microphone signals, or just like the microphone signals, we had a second input coming in to that. And so we've got this mixer bus here and coming in there. The problem is that both of these signals are using the same return current path. So there's going to be the sum of these currents is going to be going, the sum of the current through R9 and R10 is going to be going through R22. Right? So that's basically the two other halves of the balanced signal are getting combined into one signal. And with twice the current, we want the same voltage drop. And so to get the same voltage drop with twice the current, you need half the impedance. V equals IR. So for the same V, if I is twice as big, R needs to be half as big, right, to get the same V. So because we have combined the negative sides of our balanced input into a single line, that line needs to be half impedance of what these are. Does that make sense?
Yep.
Okay. So that's why we dropped these to 500 ohms. And then, yeah. So basically on this side, we're using capacitors for the isolation. And on the other sides, we're using transformers for the isolation.
Yeah. And I think the reason I stuck the no, that's headphone audio. Yeah.
Both work.
I probably just saw it on a diagram and copied it and didn't know exactly why.
Yeah. Yeah. Both of them work. Capacitors are a hell of a lot cheaper than transformers. But if you're doing truly balanced stuff, transformers are definitely the better way to go. But this is all really single-ended, so you can get away with doing capacitors. It's not that big of a deal. But in any case, the way it is being used right now, that op-amp will try and remove any common mode current coming in on those signals. And then again, we want to have this be a unity gain amplifier, so I think you want to replace RV2 with a fixed value, which would be a 1K. Oh, so close.
So, you said 1K?
Yeah.
Oh, yeah, because...
Yeah, we want it to be the same value.
The other side.
Right. So, yeah, clean that up a bit.
Whiskers. Is that like a technical term or is that like a mark term?
It's a good question. I don't know.
Come on, whisker. No, don't connect. Highlight.
Yeah, try and yeah, there you go. Oh no, you're trying to remove the pin on the component. Move the resistor out of the way. Just delete that whole wire.
Yeah, come on.
KiCad, everybody, use KiCad.
Yeah. You know, it's funny. Like, I've never used anything else. When I used KiCad for the first time ever, like, I don't know, 2 months ago, when I started deciding that for some of this rocket stuff, I would try designing some basic boards. Like, you know, I didn't try anything first. KiCad's the first thing I've ever used, and it hasn't been too bad to learn. But I say that post initial hump.
Yeah. All right. So the output of pin 7 is an unbalanced signal that you are correct in wanting to run through a transformer. Oh no! Get rid of 025 there. That we definitely don't want that there. We want ground A there.
That makes sense. Now, so where are we at with levels here?
So, KiCat, or excuse me, OHIS standard is headphone level, and headphone level and line level are remarkably similar.
I was gonna say,
Yeah.
I had to read a whole thing about like the definitions of levels, and a lot of it was very loosey goosey.
Yeah.
But I did take away that headphone level and line level are
Similar voltages.
very okay.
They are different impedances.
Okay.
All right, but they are similar voltages. So a line level goes into technically a 600 ohm load, although anything above 600 is pretty common. I've seen input impedances from 1K to 10K. Some hi-fi
I saw
stuff
a
is
lot
like
of
100K.
reference to 10K stuff
Yeah.
in the manual for this mixer.
Yeah, but technically it's 600 ohm is kind of the minimum input impedance. Anything higher than that will also work. You don't want to go too high because then you're pulling a lot less current and then you end up being more susceptible to noise. So I usually go for about 1K just because I like ones in my resistor values. Anyway, so line level is assuming a 600 ohm or 1K ohm load. Headphones are assuming anywhere between like 8 and 32 ohms. Right? The source of your headphone amplifier should be able to drive a load as low as 8 ohms. So dB, the power delivery is going to be greater to headphones than it is in line level because you have a lower impedance and therefore they are going to be drawing more current for the same voltage. But the voltages are the same, roughly, hand wavy. So if you put a 1K ohm load on your headphone amplifier, it will still look like a line level because it's just not it's not like the voltage is going to go up to drive the same amount of power. It doesn't do that. It just pulls less current. Like the headphone amplifier is a voltage source. So it'll supply as much current as the load is drawing. If you've got an 8 ohm load, it'll supply a whole bunch of current to that 8 ohm load. If you've got a 1K load, it'll just supply a whole lot less current to that 1K load. It ends up being a smaller dB because dB is power, but it is roughly the same voltage. So you can take a headphone output and treat it like a line level output.
Okay.
You can't go the other way.
I'm realizing too, as you're describing this, I was outthinking myself because I got very hung up on this push button on my mixer that tells me to pick plus 4 dB or minus 10 dB.
Yeah.
Because some of the channels on the mixer, basically all the ones, 5 through 12 or whatever, they don't have any gain adjust. And I'm like, well, I need to be able to adjust the gain, but like I can just twist the volume knob on the radio.
Yep.
So that's why I had that pod in here. It was like I need to be able to adjust the gain on this thing because I want to like kind of get it to I want the right lights to flash on the mixer. But I'm like as you're going, I'm like there's a volume knob on the radio. Like I just turned that.
You might want that'll be fine because all of the signal outputs from the radios are going to be normalized by your radio adapter. Yeah, that's correct.
So the only catch being, and I think I've given up on this idea because other weird stuff happens. My main HF rig is an FTDX 3000.
Okay.
And I've fiddled back and forth with stuff, and I don't know right now if my little homemade DI box, I can't remember if I'm feeding that from the speaker output or it has a line output, a line level output.
Okay.
Which that's just a fixed, like you can't adjust.
Line level outputs on radios are typically not volume adjusted.
So I think that's where I was thinking Well, I want to be able to adjust the gain so that I can get that line level closer to the like commercial equipment line level, because it'll be down in volume.
Okay,
But I
so
might just use the speaker output because that feels less complicated and like less parts to build into this box.
okay, then your radio adapter will have to bring that speaker level down so that it's appropriate to drive headphones, which is not
Right.
hard to do. You can do that with a single resistor if you know what the
Right.
power output of your power amplifier is.
Yeah, and that feels easier to do on the radio device, probably.
Less configurable, but yes.
Um,
Well, if you
yeah.
want to be strictly OHIS compliant, then it has to be done on the radio adapter because all of the
Right.
cables are supposed to be normalized. That level is supposed to be normalized.
Well, and that's I want to make sure I follow the standard, because the other piece, like, so I have this like picture in my brain of like what I'm going to change over here.
Mm-hmm.
So above my rack, I'm going to put this device, which will basically just have some short jumpers from, you know, the mixer right into this device. And then right above that, I basically just want to put essentially like a row of Ethernet pass-through jacks that I can then bring the radios to those, and then jumpers to the OHS IS box, with the theory that like if a buddy would show up with his OHIS adapter, we can just go like unplug one of the things and plug his thing into that spot, and he's got his little thing and can rock and roll.
If it were me doing it, I would probably make dedicated. Oh, you have limited number of inputs on your mixer. Never mind. I was going to say dedicate inputs for all of your radios, and then just bring out one or two
like extras.
Yeah, extra channels. If you have channels on the mixer, you know, you may want to do that, and rather than having another patch panel.
Okay.
But that's assuming you have the inputs on your mixer, which you may not. I don't know.
Yeah, well, and this mixer is gonna have to get replaced before too terribly long anyway, because I ran out of channels faster than I expected to, and it's old.
Always
and
happens.
Starting to get a little crusty. Okay, so basically, this, if I use per OHIS spec coming in, this I can just kind of pass right through to my isolation, and then basically input to that channel in the mixer. So that gets my audio back from the radio. I'll copy this stuff over to this channel 4 then, and then kind of make channel 4 clean, and then copy it back to 1 and 2.
Yep. So that should handle. Well, go back down. Let's take a look at your line level outputs. I want to look at the transformer here. Okay, your ground reference there, and then okay, that's fine. Yes.
What ratios do I want these transformers
1-to-1?
1-to-1. So it doesn't really matter if it's 10K to 10K or 600 to 600 or okay.
No.
Because that was the other thing I got very hung up on. I'm like, which,
yeah,
when you look at the transformers, I'm like, which one of these is like, they're all audio transformers.
Yeah. So the distinction there is, in theory, the amount of current going through a transformer has to stay below a specific threshold for the ferrite material in that transformer. And a 600 ohm transformer is going to allow more current for the same power than a 10K ohm transformer, or at least it can. Like, if it's designed correctly, that's what you want it to be able to do. It'll be fewer winds, but there's still 1-to-1 winds on either side, but it'll be fewer winds of a larger wire, whereas the 10K will probably be more winds of a finer wire. So there are some distinctions there. As long as you're not driving it near its limits, it'll be fine. It's not going to be the sound will be different on either side. It's going to be you'll hit the maximum threshold sooner or later kind of thing.
Okay. So if I just get all the same, I don't have to get 10K to 10K for this, for inputs, and the 600 to 600 for the mic one. Like, I just pick one. And
I would do 600 to 600 everywhere.
Okay.
Everything you're doing here will be fine with a 600 1-to-1.
Okay. Yeah, and I think that's what I mean, and I can go in and change those, but I think that's what I had looked up for all of them. But there was somewhere there was maybe these were different. I had put 10K to 10K for the ones that were from the mixer, but
Yeah, no, it's 600 to 600 will do fine on all of these.
okay.
Now, there's
Okay.
one other thing that we need to address.
Push to talk?
Yes, the push to talk.
Yeah.
So,
So I did the way I have these sketched, they are basically just all in parallel.
like all of the PTT grounds are tied together.
Yes.
Yeah, you don't want to do that.
Okay.
My recommendation would be to put an opto isolator on each of the PTTs. So you can still have one master PTT switch coming in, and you can still have switches on the front panel that enable or disable them. But rather than tying everything together, I would put a opto isolator. So drop a component. What is it? BN34? No, it's not BN. It's just search on 34. No, and it, like scroll up, all the way up. Oh,
well, I'm way down. How did that happen?
well, because opto solid state relay. Okay.
Should I just do a search on opto and see what happens?
Yeah, yeah. Is that up all the way? Device, D photo, D laser. Okay, scroll down. Display character, driver, FET, interface optical.
Interface optical. That sounds right.
Most likely it. Keep scrolling down. Oh no, those are receivers. Isolators. Here we are.
Isolator. There we go.
4N, and it was a 35, not a 34. Okay, so yeah, grab one of these. Oh, wait, no, that's not right. Yeah, bring that up again. Just select it and let me look at the... Scroll down. Next one. What in the what? Okay, hold on. Let me bring up my own KiCad.
And I guess that's because by tying the grounds all together, then you're tying the grounds of all those radios together and making a whole bunch of loops potentially.
Yep. Yes, exactly that. Isolator.
Sounds like a transformer or something. Isolator.
I used to be able to do that much better. You know, either that or I was much nerdier and thought I could do that much better. Damn, those are some complex opto isolators. There we go. EL814. That's what I was thinking of. Okay. Or an 817. They're the same thing. Yeah, EL814. Okay, so you're going to tie pin 3 on that to power ground on OHIS.
So I'm just going to do this low tech for now. So pin 3 to power ground, I think is
shoot, I don't remember. Here, let me...
Pretty sure it's 7.
Power ground is pin 7, yes. And then the top side of that to PTT, which is pin 2.
And then one side of this to ground and the other side to my PTT line.
Correct. Okay, that's also not the right one. but that's okay. It's I don't think they're bidirectional LEDs. I think it's not an AC LED or AC opto isolator. You want a DC opto isolator, but that's okay. So pin 2 goes to ground, and that's going to be real ground. And then pin 1 goes to whatever your PTT source is, and it needs to be able to drive an LED. So you may need a voltage or a current limiting resistor in series with that. I don't know where your power is coming from for the PTT switch.
Well, initially there was no power for my PTT switch.
Oh, yeah. Oh, yeah, you definitely don't want to do that because not only are you tying all the grounds together, you're also tying all the pull-ups on all your different radios together, which you definitely don't want to do. Oh, Steven said goodnight, folks, and I missed him. Sorry about that, Steven. If you end up watching the rest of this later, thank you very much for all your help tonight. Nerd Garage is hanging out with us for at least a few more minutes. How many more people do we have? Yep, our viewership has dropped. We peaked out at 9 viewers.
Everybody's scared of daylight savings time changing tomorrow, so they're trying to get to bed early.
Spring
Amateurs.
forward. Yeah. Anyway.
All right. Okay, so hold on. So we said pin 1 will connect to the PTT line, but in theory it could need a resistor in there to bring it down to an acceptable current for the opto isolator. That can figure out when we know what power the PTT is sending through. So the PTT switch itself is going to be...
Mike is looking a little haggard here. Wrong way. There we go.
So the PTT switch is really just going to be switching one of the power lines.
Yeah.
So we're going to have essentially so do I just use
honestly
the 12 volts?
Yeah, I would just go with 12. The disadvantage to doing 12 is that you're going to be dropping a lot of voltage on your current limiting resistors. But you're going to be dropping that voltage through the voltage regulators if you pulled it from one of those anyway. So you might as well just drop it closer to the LED and not put that load on the voltage regulators.
Okay. And I think I need to, so V1, V2, so I can just say V plus is going to come into one side of that. I guess it doesn't really matter, because this is going to not be tied to ground. This will be an isolated. So I just have to make sure to use a jack that's not...
yeah, I would put plus on the tip, not on the sleeve.
Okay. Just in case.
Yeah, but even there, you want a current limiting resistor in case something shorts out.
Okay. So between...
Okay. The right way to do this is a little bit more complex. I don't think you just want to put power through the switch. You want a high impedance detection through the switch with the pull-up resistor and whatnot, and then use that to switch like a MOSFET or something that'll provide power to the opto isolators, so that you're not trying to run the current to drive those LEDs through the PTT switch. I need to take a quick bio break. How much longer do you have in you tonight?
I mean, I'm good if you're good, but could also use a quick bio break too.
Okay, let's go take a quick bio break and be right back. Then, I mean, it's almost midnight your time, right?
Yeah.
Okay, you're good to keep going though after this, or should we wrap up?
I'm
Okay. Then, viewers, thank you very much for hanging out with us. We will be right back. We have been sitting here for a few hours, and I need to pee. So we'll see you all in a bit.
Yeah.
Well, I feel much better.
Yeah.
All right, I have unmuted us. We are back.
Awesome.
Eating cookie ASMR.
So my you mentioned like that type of thing. My wife watches a YouTube channel called Scandish Home. Sort of like, I don't know.
Why would anybody watch that? That sounds almost as bad as watching people lay out circuits on a schematic program. Why would anyone want to watch this?
Yeah, and that is a good point. You know, I guess it's just as valid because she does say like, "Oh, I never thought of doing that way." So yeah, you learn tricks from watching people do whatever they're doing.
I've had people tell me that listening to me lay out circuits when I'm just by myself is kind of a Zen experience for them. What?
Nice.
Mark VA3HES lost Vance's audio. It should be back now. Is he still not? Is his audio still not showing up? I unmuted us both.
I can talk and see if he can hear me, and if he can't, he can shout some more. Maybe I could sing.
Nerd Garage says, "Oh hey, look, you fixed the nasty yellow tinge in the video." No, I haven't. Worst case, in the best case, all I've done is put my desk into standing mode. No, the lights behind me are horrible for YouTubing, for live streaming. I need to go figure that one out and put some better lights in here. But okay, let's finish this up because I do kind of want to get moving. All right, so what we're going to do is you are going to put a 10K resistor between V plus and the tip of the TRS jack there. Ah, yes, not the switched part, correct.
Okay. And just connect that to the tip?
Yep. And then put ground on shield. Not ground A, ground.
Regular ground.
Yeah. Now, that node between the 10K and tip is when the PTT is not being pressed, it'll be at plus 12 volts. When PTT is being pressed, it'll be at ground.
Okay.
So what we're going to do is we're going to use that to control the gate of a MOSFET or the base of a transistor.
Okay.
Whatever we want, whichever of a BJT, I should say. Whichever we want to use to control the current going through to the opto isolators. Okay. So put a tag on there, do tilde open squiggly brackets.
Tilde open squiggly brackets.
PTT close squiggly brackets. And let's see if that does what I think it's going to do. Hit OK. Yes.
Well, that was a neat trick.
PTT active low.
Okay. And connect it to that node?
Yep, just like that. Okay, so now our active low PTT, we're going to go up to where your PTT, the rest of your PTT circuits are, like where the opto isolator was and that. Okay, so if it's active low, we could use a P-channel MOSFET. So yeah, drop a device, 2N7001. What? What? Oh, those are all N channel. If we're going to do this with active low, it needs to be a P channel. Where's my ground? There it is. 2N7000 P channel. 2N7000 complement B channel. Find a more modern MOSFET with better specs and its complement. Oh. Well, now you're just telling me that the 2N7000 is crap. Well, fine. The BS250 looks like the BS170 and 250 are kind of the complementary pairs. Oh, 3401. That's the one I'm thinking of. So the AO3400 and the AO3401. Because the reason I like those is because they are both basic parts on JLC PCB, so they're very, very, very cheap to put in your project. Okay. So P channel. I can never remember which way P channel works. The current goes the opposite direction of the substrate diode. So if I want to control current going that way, okay. So connect pin 3 to pin 1 on the optoisolator. Connect plus V, your 12 volts, to pin 2. Oh, did you actually tag it 12 volts?
Or
did you put a 12 volt
oh no,
you're
right. It was just plus V. Yeah.
I personally like using the power tags, but
yeah, I now might go through and clean some of this stuff up then.
Yeah, capital V. There we go.
Just to kind of get it all standardized, but this is getting me all in the right place. So,
and we want a resistor in there. Actually, so pull the V and the MOSFET down enough space to put a resistor between it and the optoisolator. No, not there. You want it not between there? The optoisolator and the MOSFET.
So between.
So you have to drag the MOSFET down.
Okay.
Yeah. And then stick a resistor in there.
Do we know what value we want on that one?
Okay. So the way we choose the value on this one is we're going to assume that the LEDs in the optoisolator are going to drop 2 volts. Okay. And we're going to have 13.8 coming in. And we want it to pass probably like 10 milliamps. Because I think the resistors usually the diodes usually top out at 20 milliamps. And the brightness difference between 20 milliamps and 10 milliamps is almost unnoticeable. So like anywhere between 5 and 10 milliamps is about right for an optoisolator. So 13.8 volts from the supply minus 2 volts leaves us with 11.8 volts. And we want to get about 10 milliamps from 11.8 volts. So V equals IR. Let me get out my trusty dusty calculator. BC minus L.
Milliamps.
11.8.
I put my decimal place.
Divided by 0.01.
1.1K?
Yeah, 1.2K is probably going to be easier to get a hold of. Yeah, so I see
quick whipped
1180.
up a Ohm's law calculator.
What's that?
Said I quick whipped up an Ohm's law calculator.
Yep. So,
1.2. I'll just want to verify that in the spec sheet or whatever opto isolator I get, right?
yeah.
Okay.
But I think a 1.2K or even a 1K, since you've already got a bunch of 1Ks on the board, that would probably do just fine. Yeah. Okay, and then put our active low PTT on pin 1.
All right, so how did we do that? That was
I'll show you. Tilde, squiggly brackets,
curly, PTT,
yep,
squiggly.
Yep.
It's like a magic trick.
It's almost like I've done this before. Okay. I think that's what you want. Now, I am much less comfortable with P-channel MOSFETs than I am with N-channel MOSFETs, but I'm pretty sure you want the voltages such that the current you are switching is going to go against the diode in the body. So you see that little diode over to the right-hand side of the schematic component? Yeah, right in there. Yes. So that is an intrinsic diode that is formed by the source and drain.
Okay.
And it's just the way the thing is created. So if you were to put a positive voltage on 3 relative to 2, it would automatically pass current through that diode. Okay?
Okay.
So there's really no way to turn that off, right? You're always going to get that, which means that's the way I remember which way to connect these things. So you want a positive voltage on 2 relative to 3 so that it's going against that diode, which means that the FET is what's actually doing the controlling here.
Okay.
Okay. There are probably real semiconductor folks who are screaming at their screens right now. It's like, oh my God, you moron. But that's how I remember it.
Okay.
So, and then P-channel MOSFETs are enabled, are turned on by a lower voltage than what's going on in the source and drain, right? So when PTT is pulled to ground, that will turn on this transistor.
Okay.
Whereas N-channel MOSFETs are the other way around. Your source and drain are down around ground, and you need to put a positive voltage on the gate to turn them on. Right? So that's why we wanted a P channel here, is because our PTT signal is active low. So I wanted something that would turn on with a low voltage.
Okay. Cool.
So I'm pretty sure that's it.
Clean this up and put those pieces together, and yeah. And then I think probably what I'll do.
Hang on for 1 second. So
yeah,
right now that opto isolator is going to turn on, or is going to press the PTT no matter what. You still have that panel mount switch 5 over on the left, and then PTT enable. So what are those?
So this was again, my thought was
like a latching switch that you
pin
use.
header, like a pin header on the board with leads going up to the button.
Okay.
Like the push button.
And so is it a push button, like a momentary, or is it a latching?
No, like a latching button. So
all right.
That button I would want to just put in this line somewhere.
Yeah.
Okay.
Exactly. You know what?
Or would it make sense to put it in here somewhere?
Yeah, save yourself a wire. Put it between pin 2 of the opto isolator and ground.
Between pin 2 and
opto
ground.
isolator. So
yeah, sorry.
Yeah, pin 2 is tied directly to ground.
Okay.
So the advantage to this is that you're not burning current for the LEDs on the opto isolator for anything that it does not have PTT enabled. The disadvantage is that you're now passing all of that current through those panel mount switches. But that's at least contained inside the box, and you know how good the wires are going to be. I didn't want to pass that current through the handheld because that's an external wire, and you don't know how thick those wires are going to be. And here also, you're only doing one opto isolator per switch, as opposed to before it would have been all of them with one switch.
Okay.
So yeah, I think that'll do it.
Okay, cool. I think my only remaining question on the back of the physical box, I wanted to put a tap on the audio. No, that wasn't that. What was I doing there? If I want to put a...
Oh, unbalanced line 2. So that's...
Yeah, if I want to put a... like tap the output there, I can just basically put an audio jack that's in parallel.
I would not recommend having an external jack that is ground A referenced.
Okay.
Right? So what I would do is I would probably put a capacitor between the unbound line 2, like another 10 microfarad, and then run that in series to your external connector and then make that ground referenced, real ground referenced.
Okay. So a capacitor to the external jack and then to real ground.
So what are you going to connect that to? A line level sync or a speaker?
So actually a little external VU board that I have that drives little VU meters that are under my desk.
I saw all the panel meters. That looks cool. Okay, so that's going to be a low current device. Then yeah, that 10 microfarad cap will do just fine.
Okay. So yeah, basically the little boards that drive these, like they can take anything from I don't know, they can take a pretty wide range of levels and there's pots on them to adjust. So
my bigger concern was whether you're going to be drawing too much current from that op amp.
Okay.
But I think if you actually put a 1K or maybe even a 10K in series with that capacitor, so that the worst case, if that signal got shorted to ground, right, you want to limit the damage that is possible to do on that jack. So kind of like the worst case is to short that thing to ground. And if you short the other side of that connector to ground, you want that to not do any harm to the rest of the circuit. Does that make sense?
Yeah. So just that way before I go out to the jack then.
Yeah. And the order of those two is not important. You could put the capacitor on either side of that.
Okay. Cool. All right.
Yeah.
Awesome. So I wonder how many if I get this cleaned up and tidied up, I should probably post these somewhere so that if somebody then wants to use this, they can feel free to take it, because I know there's other folks that use mixers, but I don't know if there's enough of them to be worth like somebody like a Halibut Electronics actually making them, you know what I mean?
This is specialized enough that I wouldn't make this as a product.
No, but I want to make sure I at least post whatever I have when I'm done with it, so if other people want to replicate it, they can shamelessly steal. I'm not proud. So
what I should probably do is put a sub page on the ohis.org page,
so like OHIS projects other people have done.
Yeah, and like, you can submit your project here and just make it available for other people to post their stuff to. All right, Steven is back. He says, "Excuse me, just thought of something. Do you need to make this a mux? If you have multiple radios on, you only want to talk on one at a time." So yes, that is what we just did with that that panel mount button right here between pin 2 of the opto isolator and ground. That is a PTT enable switch. it is not a momentary switch. It is a latching button. And so he has a row of these latching switches, and he just presses whichever one he wants to be active at any given time. I thought that was pretty rad. I think that's a really cool design.
Yeah, which was basically like so right now what I have is a rotary switch with like 6 or 7 positions and like way more wires packed into the back of it than feels reasonable.
Do you ever see yourself wanting to key up more than one device at a time?
I probably not.
Yeah, I can't think of a use case for that either, but I'm not going to tell you should rule it out. But that's one advantage of the rotary switch versus the individual buttons that can all be latched, because you might accidentally key up more than one thing at a time.
Yeah. I mean, I guess in theory.
Also, Stephen, before you took off before I had a chance to say thank you for all of your help and feedback today. That was really cool. Thank you very much. Okay, sorry, go on. I wanted to say that before he took off again.
Took off, yeah. Yeah, no, I can't think of a use case where I'd want to be talking on 2 radios at once, essentially.
Yeah.
The other thing that I'm now trying to decide if I want to do is like I think of like the other miscellaneous things that I have connected to my mixer, and I'm almost like, do I want to make a radio device like but that goes to something that's not a radio, like for my phone or for a computer or because if I had like a radio side device that I could plug my phone into, then I can just plug my phone into this whole contraption too. So
phone
and that could be cool.
USB codec is the other idea that I had for a radio device.
For when a phone,
when I get around to my
use case,
when I get around to my station console, it is high on my priority list to make a USB radio device. So it presents a radio port on one side and a USB sound card effectively on the other side. And that way I can, listen to my music in through my station console in my headphones while I'm working, but I can still be monitoring the local repeater or the adventure channel or whatever.
Well, the phone, making a user device for a phone, I could see in an EOC, an emergency operations center, that being a huge benefit, because if you think because it gives you the ability to basically do like manual phone patch. So you're on HF with somebody in a hurricane zone, but you're on the phone with their family member who's just,
and you
in
can
the
hear
same area as you are, and you can
hear both of them. You would have to do something to patch it together, or like the way you have.
So in my case, I'd just patch it together through my mixer.
Through the mixer,
just send the output of.
Yeah. My station console probably won't have that ability,
but it would still benefit. Still in an EOC place, that would still be a good benefit there, because like you would just be acting as the relay, but it would be a real-time live relay. Okay, she said. Okay, he said.
And it's effectively having 2 phones, one up to each ear, right?
Yep.
It's effectively like doing this.
Yep. Well, then you just flip them over, right?
That's the part that have the phone 69 each other. Yeah, that's the part that I do not plan on supporting in station console.
Oh my. Very cool.
Yeah.
Yeah, so that was a ton of help. And
so actually so you've got transformer isolation on the microphones going to the radios.
Microphones, yes.
Right, so down at the bottom of the screen, the transformer in the middle on the bottom. Yeah, all of those. It feels a little weird to me to have a transformer on the microphone, but then use capacitor decoupling on the headphones. It's just asymmetric. Like, they'll both work. And the advantage to having the transformer on the microphone line is that you can then make your radio devices truly balanced. Like if the receiver on the radio device is truly balanced, then that'll work just fine. And yeah, I'm being pedantic. I think that's fine. Because you got capacitors decoupling the headphones, you got a transformer decoupling the microphone, and you've got an opto-isolator decoupling the PTT. The only thing you're using VCC for is to turn on that LED to know when you have link. So it's not tied to a common ground or anything. Yeah. Oh, shoot. Yes, it is. Go up to the OHIS port on port 2. Yeah, you want to... Oh, haha, never mind. Nope, I was reading that wrong. Where's power ground? Pin 7?
7, yeah.
So you're only using power ground to power that LED. Oh, no, you also have it tied to the shield. Okay, you want to take that power ground off of the shield and tie the shield to local ground. That's what I was looking at. So you want that shield tied to local ground.
Which I have here somewhere that I can copy.
So as you lay this out, you want to make sure that you are treating signal grounds and shield grounds separately. Right? So you can have like a giant copper pour that is your shield ground and tie the shields of the RJ45s to that.
Okay.
But where you use power ground, try to run that as a separate trace that is not connected to the shield ground. Okay. Right? And then try and run all of those traces back to your power supply.
Okay, so this...
Right, so you're going to have the V- coming out of the socket, the barrel jack there. It's going to go underneath the grounds for both of your voltage regulators, right? So you're going to have a plus 9 volt and ground underneath the capacitor of C9, right? And you want everything to be, and then you want the ground side of C9 and the ground side of C12 to be as close to each other as possible.
Okay.
Okay. Actually,
do I need a separate ground?
Nope. Okay, so on the top of C12, take that ground A and rotate it 90 degrees to the right. So I think it's 3 times to the left. Okay. Copy C12.
Copy C12.
Yep, and put it on top of C12.
Copy C12 and put it on top of C12.
Correct.
Like rotate it around
Nope.
way?
Do not rotate it. Leave it just like that.
Polarity.
Yep, and then put 9 volts on top of that. You need to select the thing, not just the text.
There we go.
Will it handle 100 volts? Will what handle 100 volts, Stephen? Oh, if you're talking about the PTT lines, no. No, these opto-isolators are not meant to handle high voltage. For like a tube rig or something like that when you're switching plates, or I saw someone talking about a hybrid that's only up to 65 volts. No, those opto-isolators I think are good to 30 volts, maybe 40. So fine for like TTL level pull-up resistor kind of stuff, but not for direct switching of high voltage. Okay, so now you have decoupled your analog ground to both the positive and negative power supply ranges, okay, which is good. So anyway, so now you've got a ground your put those power supplies as close to each other as possible, and then have all of the grounds feed out of that spot, all your ground A's feed out of that spot, and all your 9 volts feed out of that spot. Like, what you want is a star configuration. You want to choose one point close to your power supply that is the source for all of these things. And then you run separate traces from there out to all the consumers of that signal.
Okay. So you don't want to, like, daisy chain them?
Correct. You do not want to daisy chain them. You want them all to have their own star.
Own path back. Okay.
You know what? It might actually be easier for the purposes of shields. Does he have any radios that have high voltage on the PTT? Older radios do this. Okay, yeah, no.
No, I don't have any old stuff.
Yeah, so...
Well, I mean, old being relative.
Yeah, nothing that has a high voltage PTT switching.
No, yeah.
Okay, go out to the power source. The not the component picker, but the ground symbol on the right side. What the hell is that called?
Oh,
that one.
Thing.
And look for Earth. That is the one that I use. That's the symbol that I use for shielding.
Okay.
Whenever I want to do a shield. So I would put that.
So I should.
Yeah.
Put that on the shield, and then
take ground off of it.
Yeah.
If you just delete that, all you did is delete the text.
Yeah.
Yeah, there you go. So put that on all the shields.
Do I want to put that on?
Yes,
should
you
these
do.
Go to that instead of.
Yep.
Okay.
Exactly that.
I feel like some of this makes a little bit of sense.
Yep.
So that would be the case for like all of these that are going to end up connected to the mixer. They want to go to that Earth one, right?
I think so, yeah.
Yeah, okay. Cool. Yeah, and I could go in and do more of those then, obviously, but...
Yes, you are nerdier.
Who's nerdier?
I don't know. The problem is that the chat is delayed from... Or the stream is delayed from us, and so they're responding to things that were, a minute ago or whatever. And so I've already forgotten it at that point.
Whatever that delay is, yeah, okay. So I just go through and do those. I can keep doing that. Okay.
Okay, and then there's one more thing to do to tie those, but you came back. I do appreciate you coming back. Mic isolation.
So my holes on the actual board,
those should be Earth now as well.
Earth.
Yeah.
Yeah, okay. Because they're going to go to my box. And I found a box that I want to put all this in. So that's like half the battle is finding the project enclosure. It's basically I think it's actually a 2U size box, but yeah.
Nice. All right, there's one other thing we need to do. Go back up to the power supply section. So right now we want to make sure that the shield is tied to ground, but we want to control where that shield is tied to ground. By splitting these out into 2 separate nets, it is not going to try and attach, like if you put a via underneath a ground pad, it won't attach that to the copper pore. Because your copper pore will be Earth.
Right.
And then ground will be its own trace going back to the power supply. But we do want the Earth, we do want the shield tied to ground at the ground supply, or at the power supply. Right? Actually, probably at V minus, right there on the power connector. Good night, Nerd Garage. Thanks again, and thank you, Steven. No. You can't do that.
Out there.
So if you do that, it will merge the nets, and it will make ground and Earth equivalent. We want to keep them separate nets. So there is a component that lets us do this. Go to the component picker.
Okay.
And look for net tie is what it's called. So 2-pin net tie, just like that. And you're just going to put it.
See.
Yeah, and you're going to put ground on one side and earth on the other side. And then net tie is an actual board component that has two pads on it, and those two pads are connected.
Okay.
And so you get to place the net tie where you want those two things to be connected. And when you're laying out this board, put that net tie very close to the power supply. Yeah.
Okay. So maybe I should just put it there so I remember that.
Yeah.
Whoops.
That didn't work.
Did I get them all?
You did now, yes.
All right. So that wants to go near that stuff.
Actually, you know what? I think connect back closer to the power connector where you had it is probably right.
Okay.
Yeah. Yeah, I think that's probably the better spot for it.
Cool. And then the power connectors, little shield connection.
Careful with that, because if it's literally a shield on the power connector, then you should tie that to earth. But most of the 3-pin barrel jacks sockets that I've seen, like one of them is the center pin, the other one connects to the outside, and then the third one connects to the second one when there's nothing plugged into it. Right? So it's a switch to determine whether something is plugged in or not.
So for my case purposes, I just leave it hanging.
Leave it hanging. Okay. Or worst case, connected to V-, because I can never remember which one's which. And so I just tie both of them to the ground. But it depends entirely on what component you're using.
What switch you end up getting.
Yeah.
Okay. Awesome.
I think that's it.
Very cool. Yeah, and probably what I'll do is, I'm going to clean all this up and I'll do some layout. And I suspect what I might do is order enough parts for like the power supply and kind of like the input stuff and like one channel.
Mm-hmm.
And I might stick them all on like a breadboard first, just to make sure it makes sense to me. Only because of the physical size of this, because I wanted to kind of fit that like rack unit 19-inch wide by whatever.
Mm-hmm.
It gets like, at first I was like, well, I'll just make the board the same size as the box so I can just put the board down in the box and I'm done.
But except you can't.
It would have been a board with a lot of empty space on it, but it was like, it was more than $100. It was so I'm like, well, like if I make it like 19 inches wide but only like 4 inches deep, then it's only $30. So maybe I'll do that.
And then you just have to put connectors,
put little pigtails.
Pigtails,
yeah.
So,
yeah,
very cool.
So
I love it.
Awesome. Yeah, this is awesome. I appreciate all the help.
You're basically designing the station controller, except without the mixer.
Yeah, well, and that's, it's funny, the one of the last couple episodes of Workbench, you mentioned the station controller, and it's the one where you were describing that like fancy little power supply thing. Or
Yeah.
You were describing the fancy little power supply hijinks you had to go through, and at first I went, oh no, I don't have to do that, do I? That sounds complicated. And then I went, oh no, this probably has to do with because he's mixing them all together, and I'm mostly keeping the channels separate except for the mic.
Yeah. So it's you're addressing that same problem by using that 4.5 volt regulator.
Okay.
Right. So the problem is that for audio, you really need 3 power supplies: a ground, and then power on both the positive and negative sides of your ground. The ground is the point around which all of your audio signals oscillate, right? It is the midpoint of your audio signals. And if you can do a true positive and negative power supply and use your real ground, there are certain advantages to the circuit to do that. If you've got a real positive and negative power supply. The problem is that when you're coming from 13.8 volts plus or minus 15%, and ground, right? You either have to take your 13.8 and do some hijinks to generate a negative version of that. And now I've got ground and plus and minus 13.8. Or you do what we just did, where you have ground and 13.8, and then we create something in the middle of that. And now that new thing in the middle is our ground, our analog ground, and then real ground is our negative supply, and plus 9 volts in this case is our positive supply. So there are various different ways of solving that problem, of getting a third power supply, or a third power node, if you will. So here we just used a bias voltage or a virtual ground.
Okay.
And then the other circuit that I talked about on the podcast was a way of efficiently, i.e. using switching circuits instead of linear circuits, converting from 13.8 plus or minus 15%, some wildly variable input voltage, and getting a solid clean plus and minus 5 volts out.
Okay.
And so now with my plus and minus 5 volts out, I have a 10 volt rail to rail audio power supply with a real solid ground. And that allows me to do some other things. Like you don't have to have any capacitors or transformers in the line. Not only does it simplify your parts count, but it also means that you're not... a capacitor is a high-pass filter, right? Because DC is basically 0 hertz. So you want to block 0 hertz and pass all the analog. So that's a high-pass filter, right? So those series capacitors are high-pass filters. And as long as your capacitor is big enough relative to the load impedance, then that cutoff point is going to be pretty low. But for us audiophile nerds, those capacitors have impact on phase noise way farther out from where they have impact on amplitude. And so I try to, if I do have to have a capacitor in line, I will try to always design it for 3 octaves out from where I want it. So like so the DC blocking capacitor, we want to pass 20 hertz, right? 20 hertz is our frequency of interest. I will try to go 3 octaves down from that. So 20 to 10, 10 to 5, 5 to 2.5. And so I will make sure, I will design my circuits to pass 2.5 hertz and block DC. But then you get all kinds of other problems when you do it that way. Like thumps and when you turn it on and that kind of stuff. So having a real ground simplifies a lot of this shenanigans. But none of that really applies in this particular situation.
So what I think might be my actual final question, I think I've had 3 final questions.
Man, it's 3 hours earlier for me than it is for you, so go right ahead.
When the transformers I was looking at are fairly inexpensive. They were rated, I think, 200 hertz to like
communication
15K.
grade.
They're like communications grade. I think that's fine. Like, how much difference does it actually make though? Because if you look at like the audio grade transformers, they're like 50, 60, 70, $100+. And I'm like, I think I'm going to use this $6 one that looks like it's like telecommunications grade.
Since it's coming from your radio, it's going to be totally fine.
Right.
Your radio, they are roughly the same grade as your radio.
Okay.
Now, if you were trying to pass, full 20 to 20K through that, you're going to notice it. You will definitely.
And that's what I was kind of curious. Like, our radios, like we chop all that off anyway because we lose most of it in our bandwidth that we use. So
you don't want to listen to the PL tones coming from your radio. So the 200 hertz cutoff is not going to be a problem.
Okay.
And your upper limit on an FM signal is going to be 3 or 4 kilohertz. So as long as it's there or above, you're not going to be losing any of that. If it's below 3 kilohertz, then you're going to start losing sibilance, which makes all of the audio understandable. So I would personally, I would rather lose low end than high end. when I'm
Okay.
trying to do communications.
Cool.
So, any other last questions?
I don't think so. That's I'll have some stuff to clean up and lay out during some of the upcoming boring meetings this week,
That's right.
And then I might start ordering some parts.
Yeah. Go ahead and run the design by me again when
Sure.
you've done all of those changes, and we'll take a look at it. We may or may not live stream that. We'll see.
Okay, cool.
Do we still have anyone watching? We are at 4 watchers right now, 4 viewers.
So is that like the people who fell asleep and left it on?
Yeah, probably. Thank you all for joining us today. Why don't you stop your screen share and we'll go back to our faces.
Yeah.
And here we are. Thank you all so much for joining us today. Vance, if anyone wants to get a hold of you, how should they reach you?
My email address is good on QRZ. I'm very hit or miss on email, so Mastodon is probably the easiest place to get a hold of me because that's the place that I check most frequently. So I'm just at N3VEM at mastodon.radio. So
Very good. I can be reached at mark@halibut.com by email, at Smitty at halibut.com on Mastodon. I've also let's see here, Ham Radio Workbench podcast, and I do have a Patreon if that is your cup of tea. If you go look for Halibut Electronics on Patreon. And let's see here, my company, Halibut Electronics, is electronics.halibut.com. I'm just going to plug all the things at the end here.
are you in the new place right now?
The new shop? Yeah, this is my shop.
I saw the plywood walls and stuff. It looked
Yeah.
like what you had been describing, so I figured you were in the new shop.
Yeah, I got one of these days. I'm going to go around with a handheld camera and just live stream a little tour of the shop.
Very cool.
But have not done that yet. I need to do that. Nerd Garage 73, Mark and Vance. Thanks for the education. Mark VA3HES is 73 gents. Learned a lot tonight. Thank you all so much for hanging out with us. And yeah, we'll catch you on the flip side. Thank you so much, everyone.
Yep,
We're going to
73.
wave, and now I'm going to look for the wave in the stream because it's way behind. And once I click stop stream, YouTube will actually still be streaming things. It's weird. Did I already wave? Nope, there I am. And there's you waving. Okay.